Hello.
Good evening, sir.
Good evening, madam. Can I share the presentation?
Uh, Sir, no, sir. Small welcome address is there, sir.
Okay. Go ahead. Okay,
Thank you, sir.
afterwards I'll explain. No issue.
Thank you, sir.
Thank you.
Sir, Ramshishu, sir. Sir, just 5 more minutes, sir. We'll start this session, sir.
Okay, Naman. Okay.
Okay, sir. Thank you, sir.
Hey.
Am I audible, sir?
Yes, madam, audible.
Thank you, sir. Good evening to one and all. I, Miss B. Ramya, Assistant Professor, gives me immense pleasure to welcome you all to the Day 2 Session 1 of our ACT ATAL Faculty Development Program on Sustainable Practices and Innovative Trends in Civil Engineering. A warm welcome to our today's resource person and all the faculty participants who have joined us from different institutions across the country. Yesterday's session set an inspiring tone, and we continue today with more distinguished speakers and exciting topics. We are privileged to have Professor D. Ramsheshu sir from NIT Warangal to deliver a session on innovations in concrete for green and sustainable infrastructure. Before we begin the session, Ms. B. Ramya shall formally introduce our eminent speaker to the audience. It's my pleasure to introduce our resource person for this session, Dr. D. Ramasheshu, Professor of Civil Engineering, NIT Warangal, was born on 15th August 1964 in Khammam. He had obtained from BE from Osmania University of Engineering, Hyderabad in 1985, MBA from IIT Bangalore in 1987, and PhD from NIT Warangal in 1995. Professor Ramasheshu has joined NIT Warangal in 1990 after working 3 years in KITS Warangal. He has more than 35 years of teaching and research experience. He taught several courses at BTech and MTech level with a good practice of sharing latest practical information. Professor Ramsheshu sir has 5 patents granted and 1 patent filed in the field of concrete materials and structures. He has guided more than 100 TZ dissertation works and supervised 6 PhD in the field of structural engineering. He has more than 130 research publications to his credit in international, national journals and conferences of reputed related to concrete materials and structures. He has carried out several consultancies which include design of scaffolding bridges, punch entry and underground mine support system for SCCL, blast fence for Hyderabad Airport, design of prefabrication yard Veligonda tunnel project, structure soundness of estate and factory buildings of Audience Factory Medic, and load testing and entity evaluation of bridges, PEB structures, repair and rehabilitation of concrete structures. Professor Ramsheshu sir has received Outstanding Concrete Engineer Award for the year 2023 from the Indian Concrete Institute, Ultratech Warangal. He is an alternate member of BISCD Concrete Subcommittee representing NIT Warangal, member of Institution of Engineers, and member of Indian Education. He is a reviewer for AAC materials and educator of PhD thesis. He is a member BOS and Research Advisory Board of several universities. He has been delivering keynote and extension lectures at several organizations which include ESCI, VMC, INCAT, AP Genco, Osmania University, JNTU, Andhra University, SVU, and other universities. Professor Ramsheshu sir, apart from teaching and research, he also had carried out diligently the other responsibilities at NIT Warangal, such as Dean International Relations and Alumni Affairs, Head Department of Civil Engineering, Head Structures Division, in charge for Structural Engineering Laboratories, Faculty in charge for construction of G+9 halls of residence, faculty in charge for the construction of Center for Innovation and Incubation, professor in charge of Project Engineering Unit, warden of REC Hostels, preserves Teachers Welfare Association of NIT Warangal. Thank you, sir, for giving me this opportunity. Sir, we welcome you and request you to lead us through your presentation. Over to you, sir.
Okay, thank you for the introduction. I think you have to give me permission to share my PPT.
Yes, sir. We are okay.
Have you given?
Yes, sir. Given, sir.
Okay.
Thank you, sir.
Yeah, are you able to see the presentation?
Yes, sir.
Okay. Right. Thank you. Okay. Okay, thank you. Okay, good evening to you all. Am I audible?
Yes, sir, you are audible, sir.
Right. The presentation is also visible, I think.
Yes, sir. Yes, sir.
Right. Okay, I thank the authorities or organizers of this FDP program for giving me an opportunity to interact with you all. Okay. Now, coming to the today's topic, I'll be talking on innovations in concretes for green and sustainable infrastructure. Okay. So in this presentation, what I'll do is, I'll go by this contents, whatever is listed here. I'll just little bit talk about what is civil engineering, how you are going to see the civil engineering from the perspective of sustainability aspects, and what are the paradigm shifts in the certain concepts, be it a design, whatever it may be, which forced us to look for new materials actually. Actually, this particular shift only forced us to see the new materials of innovation actually. So this is what the first thing that I would like to talk. And further is why should we go for green actually? Why to go green? And what is smart and sustainable? And what are the sustainable approaches? And what are the sustainable technologies related to civil engineering? And why conventional concrete is not a green material? Then how to make the concrete green? What are the alternate materials for concrete and what are the future concrete? So at the end of my presentation, I hope you will be able to answer all these questions actually. Okay. Now coming to the civil engineering. So if you look at the civil engineering is a branch which have always faced the challenges of the future. This is the oldest of an engineering branch, the engineering which helped in advancing the civilizations and building our quality of the life. You take by starting from the construction of pyramids to the high-rise structures, or at the present we are using smart and sustainable technologies. Throughout this journey, civil engineering has played a major role, and it has helped in building infrastructure. Infrastructure means what? Infrastructure means it's a good buildings to live in. That is, for example, apartment, high-rise structures, auditorium, whatnot, all kinds of structures. Then good connectivity to the modern transportation system, be it a public transportation like through roads, bridges, or the water transportation, sanitary, gas transportations. So all these things you will find the civil engineering things. Then the good connectivity to the modern communication system, be it electric or satellite communication, building of transmission towers, etc., where the knowledge of civil engineering is being used. Then in achieving the self-reliancy means the good irrigation systems, dams, barrages, canals, flood control systems, etc., storage facilities. In all these fields, whatnot, every infrastructure activity involves the civil engineering. So today we are at such a stage that any nation's standing is gauged from the kind of infrastructure availability and growth. So by having the infrastructure, by seeing the kind of infrastructure, one can gauge how the country is developing or developed country or whatnot. Now coming to the civil engineering at the same time has seen great failures also, which has led to the development. Any failure, not it develop, it leads to the development of new knowledge, whatever it may be, and it has led to the a new kind of engineering called forensic engineering. These failures always reminds us about the significance of proper design, execution, and maintenance. Okay. Now, coming to the what are the concepts that have been changed over a period of time in the civil engineering? So, which that made us to look for the new materials with the new properties, etc. For example, if you look at here I have listed few of the paradigm shifts. There can be many. The first paradigm shift, you will find it as this. We have moved from stress-based approach to the strain-based approach. What do you mean by stress-based approach to strain? That we'll see. The second concept is we have moved from resistance of large forces to the evasion of the forces. Then the third concept is we have moved from solid mechanics. We are moving actually. We have not yet completely moved, but we are moving from solid mechanics based approach to the fracture mechanics based approach. Then the strength based approach towards the performance based approach. Then prescriptive based approach to the performance based approach. These are all the kinds of paradigm shifts that have been taken place in the field of civil engineering, which forced us to look for the new materials and new technologies. Now, coming to what do you mean by moving from stress-based approach to the strain-based approach? So, all of you might be knowing, earlier we were using the working stress method for the design of either it is steel structures or concrete structures. But now we are following the limit state method. What is the difference, basic difference between this stress-based and strain-based approach? In the stress-based approach, we always see that the stress, whatever that is going to be induced in the material for a structure, which shall be less than the strength of the structure. That is, stress is the main criteria for the design approach. But in case of strain-based approach, stress is one aspect, but the main aspect here is the strain. So that's why we are using the limit state method. The 0.002 is the strain at which the material reaches the maximum stress, and 0.0035 is the strain at which it reaches it has crossed the maximum stress and started going into the drooping stage. So there, in the limit state method, strain is the main criteria. Okay, why this kind of a shift has come from stress-based to the strain-based approach? If you see the concrete, concrete is a quasi-brittle material. Whereas the steel, we can always almost say that it is a ductile material actually. But concrete compared to the steel, it is a quasi-brittle material. In all brittle materials, the brittle materials, rather than stress, strain plays an important role. So as and when the material reaches certain strain, the failure will result in, or cracks will propagate, etc. And another aspect is, if you look at the introduction of these methods, stress-based method, strain-based method, stress-based method has been introduced into the design in 1900 almost 125 years back. Still, we are following it actually to some extent. But this strain-based approach has been introduced in 1964. Since then, we were using this strain-based approach. But in India, after 1978 only, this limit state has been introduced. Okay, so why this has occurred is during this time, there is a lot of research that has taken place on the behavior of the materials. And also, there is a lot of research on the probabilistic application of the probabilistic concepts from the point of view of safety of the structures. So keeping in view of all these things, we have moved from, most of the course of practice have moved from stress-based to the strain-based approach, which requires material that can withstand large strains. Okay. Now coming to the another paradigm shift, solid mechanics based to the fracture based. Solid mechanics, that is, in a simple terms, I can say strength of materials based design actually. Of course, that's the basic principles. We still continue to use that there. But normally in strength of materials, what we assume, what we have studied in solid mechanics, the material is homogeneous, isotropic, etc., etc. That means homogeneous means no cracks at all inside, no inherent cracks in the material. So based on that, we have not taken the crack into consideration in the design. presence of crack into the consideration, the design aspect. But later on, there are many failures that have taken place. Even though the structures were designed with great factor of safety, there were great failures have taken place. The reason is presence of the inherent cracks. Any material, any material, we cannot say that is completely homogeneous material and flawless material. Definitely, any material you take, any material in this world, it will have some kind of inherent flaws, inherent cracks. And you know that the fracture mechanics design bases its design on the concept of presence of the crack actually. Whenever there is a presence of a crack, there is going to be stress concentration near the crack tip. Not only the stress concentration, whenever the strains or stresses approach a certain state, the stresses will increase or the cracks will increase uncontrollably. Uncontrollably. So that is why, for example, I'll tell you the failure of a Titanic in 1912. The Titanic was a great ship during that time. It was built with a lot of factor of safety actually. But still, the Titanic ship, after hitting an iceberg, it has sunken into the sea, actually. It has broken and it sunken into the sea. Later on, the research that has taken place, why it happened, actually. Why such a ship which has been designed with a lot of factor of safety, why the ship has failed, actually. So later on, it came to know that the material with which the ship has been built, the material, whatever the iron or steel that they have used, they don't know that in the freezing temperatures, what happens is it loses its strength actually. It loses its strength. And first of all, not only losing its strength, it becomes brittle, first of all. Rather than losing strength, it becomes the brittle actually. The material becomes brittle in freezing temperatures. So you know that any brittle material, it cannot sustain the impact actually. So here what happened is Titanic has hit the iceberg. So there is a lot of impact on the material because of this hit. And by then the surrounding temperatures are almost freezing temperatures. By then the material characteristics have changed and it has become brittle. And because of this brittleness, whatever the inherent cracks that are present, they have propagated uncontrollably. So this was the reason behind this. So that is why since then the people are thinking about how to design the systems in the presence of a crack. So by then the fracture mechanics have taken the birth of from that particular aspect. So that is why there is a slowly we are shifting, moving from solid mechanics based approach to the fracture based. That means instead of assuming a flawless material, we have to design as if the material contains the certain amount of flaws. Actually. Now another conceptual shift that has taken place in the field of civil engineering, particularly in structural engineering. Okay, we have moved from resistance of large forces to the evasion of the forces. What do you mean by resistance and what do you mean by evasion? Resistance means we continue to resist the forces, whatever the amount of the loads that are likely to act on the structure. So based on that concept, we use, that means we keep the resistance of the structure or the material greater than the loads that are likely to act on that particular structure. That was the resistance-based approach. But we do not know. If you look at the natural forces means be it a wind force or earthquake force, whatever it may be, such forces are very uncertain forces. Uncertain. Nobody can estimate the magnitude of those forces. Even though we are giving certain areas falls in certain wind zones, but it is not guaranteed that the wind greater than such amount, whatever is specified in the code, doesn't come. For example, as far as the earthquake is concerned, India has been divided into different zones actually. So it is not guaranteed. For example, you take zone 2, it's not guaranteed that Zone 3 or zone 4 level doesn't occur in zone 2. Okay. But to the possible extent, from the probability concept, they say that 95% of the times the zone 2 level of earthquakes only will occur. That means what I wanted to say here is the natural forces is unpredictable, first of all. So then how to design the structures, how to design the structures without knowing the exact amount of the force. So from that concept, the concept of evasion of the forces have come. Evasion means try to avoid the force, that's all. How do you avoid the forces actually? That means by giving a characteristic called bendability. By giving a characteristic called the bendability, one can evade the forces actually. For example, here I have shown a small uh, picture, small picture wherein you can understand this. Here I've shown two trees actually. One tree is a large banyan tree, something like that, which has got a large trunk, etc. Another one is a slender tree, like palm tree, whatever it may be. So what happens in case of wind forces, tree thinks that, just I'm telling in a lighter way, the big tree thinks that I am so great, I can resist any amount of the wind. That's why it tries to stand erect actually. So it doesn't know that the magnitude of the wind forces. So wind uproots the particular wind. Whereas the next tree, that is a clever tree, so whenever there is a wind, it bends slightly so that the wind ego is satisfied and wind passes off and it comes back to its original state. That means the characteristic of bendability rather than erecting, I mean, rather than keeping it straight, the character of bendability has dissipated the energy, So this is the concept most of the earthquake codes uses. Even IS 1893 code of practice uses this concept. That is why, keeping in view of this, they have introduced the concept of response reduction factor. Okay, so if the force is, let us say, 100 kilonewtons of the force, we use the R of, let us say, 3 or 4 or something like that. That means, what do you mean by that? We will not design for 100 kilonewton, but we will design for 100 by R, or 100 by 3 or 100 by 4. So to that force we will design. Then you may ask a question, if you design for 20 kilonewtons of the force, how it is able to resist 100 kilonewtons? So that is why they use the concept of energy concept here. So based on that, we need a materials which can undergo large ductility. There is a requirement of such materials. So this has encouraged for the search for the new materials, etc., or encourage structural forms possessing the ductility, etc. Now, another conceptual shift, which all of you know, that strength approach to the performance approach. What do you mean by strength approach? That means people are gives more importance to the strength of the things only, strength of the material, strength of the structure, etc. But nowadays, the people are more conscious about performance. For example, if you look at the warehouses, wherein the abrasion resistancy of the floor becomes very, very important actually. So we should design that particular floor to have certain level of abrasion resistance, not to the certain level of strength. We have to design the floor for certain level of resistance, abrasion resistance. So for example, in a chemical factory, the floor has to be designed to resist the attack of the chemicals. Okay, so where there is a possibility of spillage of these chemicals, etc. That's why each industry has its own requirement. The strength is okay. Strength is by default it is taken granted, but the performance people are worried about this. So that is why when that strength approach was there, of course, we were using earlier the simple normal concrete, which is basically strength based. We have used 4 ingredients like cement, sand, coarse aggregate, water, etc. But nowadays, we are using a concrete consisting of more than these 4 basic ingredients. So we are using flash, silica fume, GGBS, etc., to impart certain special properties to the concrete. So that is why we have shifted from strength-based approach to the performance-based approach. Another thing is we are slowly moving from prescriptive to the performance, prescriptive to the performance. Prescriptive to the performance-based approach. What do you mean by prescriptive and what is the performance? Prescriptive means like that you can remember at this stage, like doctor gives a prescription. But what the doctor says, just he writes certain medicines and use the medicine, that's all. Okay. But is there a guarantee that that will reduce your problem? Yeah, likely it may reduce, that's a different issue. So that means even if the problem recurs, who is responsible for that? So in the civil engineering also, uh, instead of prescriptive, we have to go for perform. Prescriptive means suppose for a construction contractor, tender says that use some 300 kgs of cement, use round aggregate, use angular aggregates, some finest modeler this much, like that. Suppose if contractor uses all such specifications, then if the crack forms, even if there is a damage to the durability of that particular system, who is responsible? Contractor will say that I have used a part according to whatever you have prescribed. Then the performance is not guaranteed. So that is why instead of specifying the certain, instead of giving a prescription to a contractor, you fix the performance specification. Performance specifications mean, for example, in ASTM, a lot of performance specifications are there. So, for example, you can specify my floor should have an abrasion resistance of this much or low permeability of this much. That means then how to test that particular performance character actually. So based on that, the AS team has given a lot of standards to check the performance of various things actually. So based on this, what I mean to say is there is an increasing concept of this performance. Then to satisfy this performance, we have to go for new materials or alternate materials. So that can bring, at the same time, they should bring the green concepts and also the sustainability to the picture. So these are the paradigm shifts that we have discussed so far. Now coming to the why to go green. Why to go green? So you just see this, since the Industrial Revolution, the world has witnessed a lot of changes, innumerable technological changes, achievements, etc. There is a tremendous population growth. Then what happened is, because of this, there is a tremendous increase in the use of natural resources. Almost since 1950, there is a almost 8 times increase is there in the 8 to 10 times increase is there in the use of natural resources. For example, if you look at this particular figure, we are using fresh water withdrawals of the order of 16%. Whatever the available fresh water is there, we are using consuming 16% towards the building activity. Timber, whatever is produced, 25% of the timber is being used for this building activity. Similarly, raw material consumption, 30%. Similarly, for example, ozone depletion due to the chlorofluorocarbons in use is almost reaches 50% of it. So these are all the things which have a lot of impact on the environment. They are all due to the construction activity. For example, if I say one thing, in producing 900 million tons of useful material, we are producing 6,000 million tons of waste. So for producing just 900 million tons, we are producing 6,000 million tons of waste material. Then where this waste has to go, first of all? Then what is the side effects? Side effects is it leading to the pollution, leading to the landfills at capacity, toxic waste, global warming, resource crunch, ozone depletion, deforestation. All these things are straining the limits of the Earth's carrying capacity. That means the ability to provide the resources required to sustain the life while retaining capacity to regenerate and remain viable. So that means this is posing a threat to the very existence of the human civilization. So in view of these factors, there is an urgent need to go for the green technologies, adopting green technologies, but at the same time, the sustainable technologies. This assumes a lot of significance. Now, coming to the why to go green, continuation of this, keeping in view of this kind of damage to the environment, there is 17 SDGs, they call it SDGs, Sustainable Development Goals, have been described by the United Nations. All the member states have agreed upon these 17 development goals to be achieved actually. Out of this, you can see number of things: no poverty, zero hunger, good health, etc., etc. You see the 11th one: sustainable cities and communities. So under this, there is a need to go for the materials which has a sustainability in nature, etc. Okay, so from this aspect, the sustainable technologies assumes a lot of significance. So we have talked of sustainability, etc. Then what do you mean by sustainability? How the different organizations have defined this sustainability, green materials. For example, there are a lot of definitions are there, but here I'm showing you the definition by Brundtland Commission 1987. That is, the sustainability or sustainable development is the development that meets the needs of the present without compromising on the ability of the future generations to meet their own needs. This is what is simple definition they have given. Then coming to the green material. Green material is that's the material in which the production, use, and disposal of the material must be safe for the planet. So these are all the ways in which the green materials have been defined. Then what is smart and sustainable? Smart and sustainable technologies are the innovations that can help improve our quality of life for humans and the environment. So let us see, for example, continuing the smart and sustainability. So nowadays we are recalling that smart cities, etc. So what is a smart city? Smart city is the one which uses the information and communication technologies to improve a city's infrastructure and quality of the life. Smart cities can include the efficient urban planning, sustainable public transportation, and smart waste management. For example, smart agriculture. Smart agriculture that uses the information and communication technologies to improve the agricultural practice. For example, for climate management, we use the sensors for the soil, water, then software platform, GPC, satellite systems. We take the help of all these things in the agricultural practices. So then we can say smart agriculture. Then Internet of Things. Internet of Things, in this we use smart sensors and devices to monitor the systems in real time actually. So for example, water utilities can use IoT to identify the leaks wherever the leaks are there and optimize the water distribution, etc. So IoT is coming in a big way and in making civil engineering a smart and sustainable engineering. Then of course the buzzword AI and ML. These techniques will be definitely useful, wherein large data is there, wherein we can analyze the large data and can make a conclusions, useful conclusions, and later on further we can use this. Now coming to the different approaches, sustainability approaches. So there are different sustainability approaches. Here I've listed a few of the approaches. One is cradle to gate approach, then cradle to the site approach, cradle to the construction, cradle to the grave, and last one is a cradle to cradle approach, cradle to cradle approach. For example, what do you mean by cradle to gate? Cradle to gate involves For example, you see the cement production. Cement production. So cement production starts from the extraction of the ore, extraction of the required raw materials, etc. Then it will be transported to the factory, and factory there will be manufacturing of that particular cement or whatever the material. So that means it is ready to the transport. It is ready to be distributed. So till that stage, we call the concept as cradle to gate approach. That we take all precautions such that nothing, no way, the wastage is minimal in all these things. Okay. Then what about cradle to the site approach? Site means from the factory to the site, the material needs to be transported. Okay, safely without much waste and without losing its qualities, etc. What are all the precautions that you wanted to take in this cradle to site approach that will be implemented? So like that cradle to the construction. So after transporting to the site, we use the material in the construction, and during the construction also, we try to minimize the wastage to a lot of extent, etc. Cradle through the construction. Cradle to grave. Grave means, so we have constructed, we have used the material, and its lifetime is over, and it is ready for the disposal of the material. So that's why we call it cradle to the grave. But here the problem is, once the material is disposed, what to do with the disposed material? Can we convert that disposed material again back to the cycling, that is construction cycling, recycling? So that is why the cradle to cradle. That means it starts from the beginning and it comes back to the beginning of the cycle. That's why this cradle to cradle approach is being now is a buzzword. People are trying to implement in different technologies, different material and structural cycles and performance cycles. Okay. So once it completes the material cycle, goes to the performance cycle. Once it completes the performance cycle, then it has to come back to the, it's again back to the material cycle actually. Again back to the material cycle. Okay. Now coming to the smart technologies that are related to the civil engineering. What are the smart technologies here? The building information modeling, augmented reality is there, Internet of Things, digital twins. Digital twins is a very useful one, wherein we create the virtual model of the actual systems, virtual model, and we can experiment on that, how it is going to respond. Suppose if it is responding as expected, it is okay. Suppose if it is not responding as expected, then we can change our model, etc., and we can take care of the things. So these are all the certain things which are being helpful. Then the few ways to achieve smart and sustainable infrastructure. The use of renewable energy to reduce the carbon footprint, use of the recycled materials to reduce the waste, adaptive design that allows the systems and structures to change and adapt to the changing conditions, then sustainable drainage systems, smart power and water smart grid, smart buildings, green building materials. Here we are going to the green building materials to reduce the impact on the environment. Reduce the impact on the environment. Of course, here this slide gives certain objectives of this sustainable building objectives, wherein the terms like resource conservation, cost efficiency, and design for human adaptation. These are all the things which gains a lot of significance in meeting these sustainable building objectives. Okay. Now coming to the building envelope. Here, building envelope means the kind of the material that we use in a building and shape of the building, whatever it may be, how best it is going to conserve the energy. So building envelope also plays a lot of significance in bringing the sustainability into the pictures. Yeah. Now, coming to the what are the features of a sustainable building? Here, features of sustainable building includes many aspects actually. Here I've listed few things. Best building form. It uses the non-conventional energy sources, solar energy, for efficient design. then improved indoor air quality, usage of green materials, then proper mechanical systems, efficient lighting, proper testing, maintenance, etc., etc. These are all the characteristics of a green material. Then why conventional concrete is not green? You all know that conventional concrete is extensively used. It's the most consumed material in the world after food and water. Yeah, but apart from the positive aspects are extremely versatile, good strength, whatever the required strength, we can get it from the use of this concrete. Then can be cast to nearly to any desired shape. That is, moldability is the greatest advantage of the conventional concrete, etc. Uh, Apart from these positive aspects, there are certain negative aspects. What are the negative aspects? Is it's the most energy intensive of all manufacturing industry. That means consumption of the and production of cement involves large lot amount of energy. Then limited ultimate strength, limited durability. Another factor is it uses the virgin material. Virgin material, sand, coarse aggregate, whatever it may be, that's the natural materials. That is using such natural materials wherein there is a depletion of such natural materials is taking place very aggressively or fast. Then the production of cement itself is producing a lot of global warming gases. How to reduce such things? So keeping in view of all these things, we can say that the conventional concrete is not a green material. So to overcome these negative aspects, the people are suggesting the use of the supplementary cementitious materials is being advocated. Okay, for this. Then use of not only use of supplementary cementation materials, you see, by using such things, we can reduce the greenhouse gases, first thing. Then we can, at the same time, we can use the waste materials, the biomass fuels that are carbon neutral, then reducing the levels of cement clinker with use of waste materials. So all these things will lead to the sustainability. So you know that the goal is to reduce, reuse, and recycle. These are the terms which the World Building Council is using to propagate or to disseminate the significance of this sustainability in the construction. So in this context, the alternate materials or the special concretes that assumes a lot of significance. Now we'll move on to what are the alternate materials for making the concrete. Alternate materials. For example, here I've taken a sand first, river sand. What are the alternatives to the river sand? River sand, definitely, it has got a lot of advantages. It has got a particle shape, more or less it is round and smooth due to years of abrasion. Then low silt and clay due to years of washing. So offers improved workability to the concrete. So for a given workability, it reduces the water demand and thus allows the use of low cement content in the mixture. These are all certain advantages are there. But the disadvantage is it is fast depleting, first of all. Rather than certain disadvantage. Fast depletion is the most disadvantage of this particular material. Okay. Then what are the alternatives to the river sand? When you are looking for alternatives to the river sand, you should keep two issues in the mind. What are the two issues that will come up when you are going for an alternative to the river sand? One is the fine content, another is the harmful substance. Fine content means there is a possibility that alternate materials may have a more fines. More fines means more surface area. More surface area means more water demand. So more water demand means reduction in the strength actually. So that is why the fine content you have to be very careful when you are using an alternative to the river sand. Then another thing is harmful substance. Is there any harmful substances which will affect the durability of the system? These are the two aspects you should look for when you are using the alternate to the reverse sand. Then what are the alternatives? There are many alternatives that have been researched, and a lot of information is there in the literature. For example, here I have listed a few of the alternatives. One is the manufactured sand, copper slag, crushed waste glass. This is a crushed waste glass, flash, a dune or desert sand, then iron slag, foundry sand, recycled sand, okay, which is from the demolished construction waste, we can extract the recycling of the sand. Then surki, that's the brick powder, etc. These are all certain things which have been attempted as an alternative to the reverse sand, as an alternative to the reverse sand. Okay, alternatives to the river sand, there are a lot of advantages. When you go for alternatives, the wide availability of the sources will increase actually. It gives a flexibility. So, for example, all alternative sands are eco-friendly with low carbon dioxide emission, and they do not contain organic and soluble compounds that affect the setting time and properties. The most cost effective than the natural sand. Then help in reducing the dumping of the waste in landfill. Suppose if you are using flash, definitely it reduces the dumping of that waste in the landfills. Then it improves the mechanical and durability properties of the concrete. Okay, and rather than all these things, there is another important thing is there is no exploitation of the riverbeds, thus preventing the environmental catastrophes, etc. Okay, that as I told you, certain issues we have to take care. That is, one is the workability issues, and because of the larger proportion of the fines, these workability issues comes into picture. Then low moisture content, then possible adulteration is possible in the manufactured sand or manufactured materials. Okay, these are the things that we have to keep it in mind. For example, if you go for crushed stone dust as a replacement for the sand, it's okay from the strength point of view, etc. But the thing is, because of its sticky nature, it is difficult to travel. That means it's difficult to work with the crushed stone dust as a replacement for the sand. That is why whenever you are using it for plastering applications, normally a lot of wastage will be there in that, unless it is properly designed actually. Similarly, if you are going to use crushed waste glass, there is a possibility of ASR. ASR means alkali silicon reaction. So that affects the durability of the system. Then if you are going to use a copper slag, has a fewer finer particles than sand. So finer particles cannot be less or cannot be more also. Okay. Then coming to the foundry sand, the use of that increase in water demand due to the porous and large surface area. Then if you are using a dune or desert sand, there is a possibility of harmful impurities are there, such as iron, pyrates, etc. Of course, if you can limit as per the code of practice, there is no problem. Okay. Then iron slag, if you are using that as an alternative to the river sand, you should also take care of the expansiveness and undesirable reaction between slag and the components of the concrete. Okay, so these are all the certain aspects that you have to take care when you are going for alternatives. Nowadays, the sand is being manufactured using the technique of geopolymer. The such thing is called geopolymer flash sand. So they are manufacturing with the proper mix proportion, etc. And the material can be manufactured in different sizes actually, which can be used as a coarse aggregate or which can be used as a sand actually. We'll see this geopolymer aspects. Then another aspect is the alternatives to the aggregates, lightweight aggregates. Okay, lightweight aggregates like pumice, scoria, the flash plates, or expanded clay, chipped shale, expanded slate, expanded slag. These are all the things which you can use in place of and alternatives to the aggregates. But at the same time, you should look for the strength aspect. When you are going for lightweight aggregates, definitely the strength is a problematic here. So you should have a careful in mixed design and also strength aspect. Okay. Now coming to the people are using the agro waste as an aggregates, whether it's fine aggregate or whatever it may be, aggregates in the concrete because we have a lot of solid waste that gets generated because of from this agricultural practices. So how best we can use that in the concrete? For example, sugarcane, bagasse ash, rice husk ash, jute fiber. Okay, these are all the things which are available. How best we can use this agricultural waste into the proper utilization. So from this perspective, here I have listed certain aggregates, agro waste. Okay. For example, if you look at the sugar cane after its utilization, then we can burn it and sugar cane bagasse ash will come into picture. Okay, that can be used as a useful material in the concrete. Similarly, the groundnut shell. So groundnut shell, also groundnut shell ash can be produced. Groundnut shell ash can be produced. Then the oyster shells, that is aqua based actually. It is burnt and it gives a quick lime actually, quick lime. So that can be used as an alternative to the fine aggregate in the concrete. Similarly, cork shell. So natural, it's a cellulose material actually, but that also can be used in its fine state as a fine aggregate concrete system. Similarly, giant reed fibers. Giant reed fibers also after burning the ash, whatever the ash, the resultant ash can be used as a fine aggregate. Similarly, rice husk ash. You know that rice husk ash is being used there. Similarly, sawdust, then tobacco waste, then crushed coconut shell. Coconut shell that also being used after breaking it to the required sizes. It's also being used as an aggregate in a concrete generation. So if you look at the physical properties of all these things, sand, sugarcane, bagasse, or groundnut shell, etc., almost all they are having a similar specific gravities. We can size them to have a similar fineness modulus. Of course, bulk density wise, there is a little variation is there, but however, some of the this agro waste they are on comparable with the natural sand actually. Coming to the water absorption, this is an issue actually. Sometimes water absorption will be more in case of agro waste. So that has to be taken care. Similarly, chemical properties wise, if you look at the chemical properties wise, cement has these properties like silicon dioxide 17 to 25%, Al2O3 3 to 8%, calcium oxide 62 to 67%. So you can see even in sugarcane bagasse ash also, SiO2 is 62%. Okay. Similarly, groundnut shell 16.2, almost similar to this cement. Okay. So like this, the chemical properties we should take care while using because these things will affect the durability of the system. All these chemical things. Okay. Now coming to the agro waste pros and cons. Pros is reduction in sulfate, low thermal conductivity is one of the advantageous parameters. But when it comes to the disadvantages, it may result in low workability, low modulus. Low modulus means there is a possibility of slightly higher deformations. Okay, low strength and durability wise, there is a contradicting aspects are there actually. Of course, all these things I've taken from the literature. You can also go through the literature, how these agri wastes people have used and concluded. For example, slump value of the agro waste concrete containing bagasse ash, groundnut shell, oyster shell, giant reed ash, etc., decreased. That is slump value of agro waste concrete decreased as the percentage replacement has increased. So this is an aspect that you have to keep it in mind. Similarly, in case of agro-based concrete containing bagasse ash, etc., The minimum strength of concrete was achieved with the addition of around 20% replacement. So such conclusions are available in the literature wherein you can use them. Now coming to the certain special concretes, what do you mean by special concrete? Special concrete is defined as a concrete which meets certain performance and uniformity requirements that cannot always be achieved routinely by using only conventional materials. That's what the special concrete. Here, special concrete means the requirement. Coming to the requirements, it's a requirement based only. So requirements can be anything. Sometimes requirement can be long-term mechanical properties. Sometimes requirement can be volume stability. Sometimes requirement can be compaction without segregation. That means self-compacting concrete like that. So there are different requirements. Each requirement demands a different type of a concrete. So from this point of view, here I have listed certain points about the futuristic materials in concretes. What is the goal of all this, whatever the futuristic material that you are going to develop or use, all these have a certain goals. First goal is they should be environmental friendly. And of course, the lightweight, durability, repairable, and cost effective. Repairable, this is the word that you have to remember. I think I hope most of you have seen the draft IS 456, draft IS 456 code actually. Then the draft IS 456, there are a lot of changes they are doing it. What are these changes is in the present code of practice, there are only two limit states are there. One limit state of collapse and limit state of serviceability. Of course, the durability is also there. That can be taken as the limit state of durability because we have to satisfy the criteria of durability. So present code has incorporated three limit states. But in the draft code, apart from these three limit states, they are going to incorporate the three more limit states. Apart from this, what are those three more limit states? Is limit state of integrity, limit state of robustness, and limit state of restorability. So from this restorability point of view, the repairability aspect comes into picture. How is we can repair the material? How is the repair the materials? So from that point of one has to be selective while selecting the materials. Then futuristic materials, not only they should be environmental friendly, lightweight, durable, repairable, they should also address the space shortage and energy efficiency. Then should have adequate strength and integrity, robustness to address the natural and man-made calamities. So these are all the certain requirements of future materials and what are possible futuristic materials. The possible futuristic material, here I have listed few things. One is the nanotechnology based materials. Nanotechnology based materials for high strength and high durability applications, we can go for nanotechnology based materials. Then biotechnology based materials. That is for self-healing applications, people are going for biotechnology, bio-based concretes or bioconcretes, etc. Then super hydrophobic materials for waterproofing applications. Super hydrophobic means normally the problem with the concrete is in a long-term problem is the seepage of the water into the system. So if you can make it as a hydrophobic, then we can improve its waterproofing characteristics, etc. Of course, the lunar materials to make colonies on the moon to overcome the space shortage on the Earth. Similarly, another requirement is security protective materials. So as far as I told you in the IS 456, so they are making, they are introducing three more limit states. One is limit state of integrity, limit state of robustness, and limit state of restorability. In this concept, limit state of robustness, integrity and robustness. So whenever the materials or the structures exposed to the chemical or explosive attacks, etc., there should be integrity of the structure. It has to be preserved. Similarly, robustness. Robustness means there should not be disproportionate collapse to the cause. Suppose the cause is very small, the structure cannot collapse completely. There can be small damage locally, but it cannot collapse completely. So those aspects, having it as security protective materials. Okay. So research is going on how best we can improve this the resistance under impact loads. For example, using fiber reinforced concrete, etc. How best we can increase the impact resistance of the concretes. So now, at this stage, what I show you is certain concretes based on the criteria, that is low cost concretes, lightweight, heavyweight, underwater, ultra high strength, ultra durability, reduced environmental impact, fast setting, etc. Those things I'll show you. Okay. Now coming to the these things. Yeah, that's right. And now, coming to this low cost concrete, how we can achieve this low cost concrete? So, one is by using fuel ash, that is flash. So, flash, with the use of flash, one can reduce the actual cement content. We can reduce 25% easily, can be replaced or reduced cement content. Thereby, you can have some low cost concrete. Then, using higher volumes of flash. Of course, for structural applications, high volume flash concretes may not have they have limited structural applications actually. Similarly, using GGBS, one can go for the GGBS, 15% can be replaced. Then condensed silica fume can be also be used in producing low cost concrete. But here, at present, this condensed silica fume is little bit costly. Okay, whenever its production is available, then it becomes a cheaper. Otherwise, it is also costly one. Okay, then using this water reducers. Water reducers also one can reduce the cost. How? Whenever you are going for water reducer, you require less water content. Then to maintain the water cement ratio, you should also reduce the cement. You should also reduce the cement. So thereby you are using low quantities of the cement that helps in producing low cost concretes. Then lightweight concrete. You all know that lightweight concrete has got a lot of applications actually. So in this, I can say that lightweight aggregate concretes, okay, are forward concrete, are no fines concrete. Lightweight aggregate means we are using aggregates which have got certain good thermal properties. Such concrete will have good thermal properties. Then forward concrete. Here there are several routes are there, several ways we can produce lightweight concrete. One is a no fines concrete. It is a structural, but it's a permeable concrete. Forward concrete. It is normally used for non-structural applications only. Similarly, for normal paste and lightweight aggregates, if you use and produce a lightweight aggregate concrete, so that can be used for both structural and non-structural applications. So here, lightweight means its density will be very less compared to the normal concrete. Okay. Similarly, these are all the various aggregates which can be used for producing the lightweight aggregate concretes: pumice, scoria, flash, expanded clay, chipped shales, etc. These are all can be used. Okay, this slide shows you the applications of formed concrete, how the formed concrete is being used. Then coming to the heavyweight concrete. Of course, heavyweight concrete has limited applications. Okay. Limited means only special applications. For example, if at all concrete needs to have a protecting and shielding places with greater risk of radiation, then we go for this kind of heavyweight concrete with use of heavyweight aggregates. For example, barrettes. which have got a 3,500 kg per cubic meter, magnetite 3,900, steel shots 5,900, like that lead 8,900. So when you are using heavier aggregate, definitely it will have a heavier concrete, heavyweight concrete, which can shield the radiation in a better way. It can shield the then underwater concreting applications. So underwater concreting application, there are a lot of technologies are there. Another one thing is condensed silica fuel. Then we can also use non-dispersal admixtures. Then using these non-dispersal admixtures, concrete preserves the cohesiveness actually. So that's why it can be placed underwater. Okay. Now coming to the ultra high strength concrete. Ultra high strength concrete. So normally the strength of concrete here almost approaches more than 120, 150 MPa concrete. So in that category, reactive powder concrete assumes a lot of significance. Reactive powder, with the use of this reactive powder concrete, people have produced a concrete up to 200 MPa. So, and also having a lot of ductility. With use of the low water split ratio, silica fume, fine quartz sand, these are all the ingredients for the reactive powder concrete. Then steel fibers, high dosage of superplastizer, etc. These things they are used for producing the reactive powder concrete. They've got a superior properties and for specialized applications. Almost we can go compression strength of 200 MPa and flexural strength of 50 MPa. Okay. Then modulus of elasticity 45 to 50 GPa. Then low capillary porosity. So these are all the advantages of this RPC compared to the normal concrete. Okay. These are all some of the applications of this RPC. Then ultra durable concretes. Ultra durable concrete. Here, you should understand the concept of durable. Durability means it is the concrete system will have some durability because of certain inherent nature. Then another thing is the durability gets affected because of the aggressiveness of the environment, not the concrete, aggressiveness of the environment, the system gets damaged. So there are the two ways durability can get affected. One is by internal system, another by aggressiveness of the external things. Okay. So now coming to the how we can produce this ultra durable concretes. So there are different technologies are there. One is uh, minimizing the amount of water added. Then using superplastics. Then using wide particle size distribution and packing. Then another technology enhancing the fragmentation resistance by incorporating fibers. Then use of controlled permeability formula. These are all the various technologies by which we can produce the ultra durable concrete. What is this controlled permeability formula? CPF. CPF, this is the one which enhances the concrete surface quality by draining the excess water and air while retaining the cement and fine particles. Just a minute, yeah. I have small. Sorry. Presentation. Huh? Online presentation on Monday. Yes, and then we talk about like the kind of Pawan? Pawan? నేను presentation నడుస్తాం
Hello, sir.
Yes. Yeah, I'm continuing.
Okay, sir. Thank you, sir.
Right. Okay, there are different technologies which I've spelled out. These are the minimizing amount of water added, etc. Use of this controlled permeability formula. So this results in a loss of water from the concrete. So thereby we get a lot of stronger concrete cover zone where the cover of concrete is perfect. The ingress of the atmospheric agents gets reduced. Thereby, the system gets durability of the system gets it. So these are all the various technologies by which one can have the ultra durable. So in this aspect, the nanotechnology is coming in a big way. Nanotechnology, which has got a lot of impact on engineering. So what is this nanotechnology and what? You know that nanotechnology, the material size is equal to -9, the size of particles. So then what are the various nanomaterials that concrete we can use? One is a carbon nanotubes. CATs, whether it is a titanium dioxide, zinc oxide, then tungsten oxide, etc. These are all the various nanomaterials that are being successfully used in producing the high durability concretes. So if you see the nanosilica is the one which control the degradation of the fundamental CS CS means calcium silicate hydrate. That is the one which is responsible for the durability of the system as well as the strength. Okay. When the CSH gel is denser, then definitely we can expect more durability of the system. So when you use this nanosilica, it blocks the water penetration and therefore leads to the improvements in durability when related to the OPC. So with the result, both the compression strength as well as the life of the material is also increased by 3 to 6 times higher. Then another technology is the use of carbon nanotubes, CNTs. Okay, CNTs, we can use the CNTs. We can produce the compression strength increase by about 70%. Then we can also reduce the heat conductivity by about 12 to 30%. And most of the important aspect of the CNTs is they are going to bridge the micro cracks. Once the micro cracks are bridged, the crack widening get delayed. So thereby durability of the system gets increased. Okay. Now coming to the, that's why these CNTs are being used in producing the self-sensing concretes. Self-sensing concrete means wherein we can embed the sensors. The CNTs, whenever the concrete is stressed, so those things we can have a recording or can connect it to the data acquisition system, and we can measure the stresses induced in the system. Okay. So that's why the self-sensing system you get. That means the concrete possesses the piezo-resistive properties or piezoelectric properties with use of these carbon nanotubes. Then another thing is the self-cleaning of the buildings. Self-cleaning means that normally the technology that is used TI wood, that is titanium dioxide, is applied in a layer of a concrete. So what is the advantage of this TI wood is it doesn't get the dust doesn't get sit on the that particular surface. It cannot get attracted. So it helps in the self-cleaning nature of the buildings. Okay. Now, concrete with a reduced environmental impact that can be produced with the use of pulverized flash, GGPS, and etc. And in this context, no fines concrete is there. No fines concrete, which is also known as the pervious concrete, that can reduce or eliminate the runoff from the roads and prevent the flooding and pollution. Okay. Similarly, you can also use the GGBS, which can produce a bright white concrete surface, which reduces the heat island effect, particularly in the urban climate, we require this kind of technologies wherein heat can be reduced, heat effects can be reduced. Okay. Similarly, this slide shows you the pervious concrete. This slide shows you pervious concrete, wherein the rainwater gets absorbed into the ground, thereby runoff of the water gets reduced. Okay. At the same time, ground is also getting recharged with this pervious concrete. Okay. Similarly, fast setting for precasting applications. So this can be achieved with use of superplasticizers or by going for high temperature curing and autoclaved concrete. Using autoclaving techniques, one can produce the fast setting concretes. Okay. Then the placing of the concrete without formwork. You know this technology that is called shotcreting or graniting of the structures, wherein we can use the without formwork, we can work with the systems. Okay. Similarly, concrete that is suitable for bulk fill applications, that is controlled low strength concretes are being used for such application, bulk fill applications. Bulk fill applications means suppose wherein you dig a trench. Suppose if the trench is backfilled with normal soil, what happens? It takes a lot of time for the setting. Instead of that, if you go for a CLSF material, we can achieve the stiffness of that particular system at a early time, at a less time. Can So next is self-compacting concrete. All of you, I might be heard of this self-compacting, might have worked on self-compacting concrete there, which has got a lot of advantages there. Without using the compaction, one can cast the systems actually. Okay. Then these are all the self-compacting concrete issues. I mean, wherein one of the aspect of SCC is we have to use a high fine content of the material. That is why density of the system will be different from the normal. That's why a lot of work is going on, how it will resist the cracks, how the density of the system affects the other aspects like crack propagation, etc. These are all the research that is going on in this. And for self-compacting concretes, there are a lot of new tests are also developed. For example, J-ring tests, V-funnel tests. Apart from slump cone, these are all the new tests that have been developed. That is L-box test, okay, U-box, and J-ring test, etc. These are all the new systems that have been developed. Now coming to the another type of concrete is self-healing concrete. That is, we call it the bioconcretes actually. Okay. So in this self-healing, material is introduced into the system. If you introduce the self-healing material into the system, whenever the crack forms, crack gets closed with the bacteria that is going to release the self-healing material into the concrete system. Okay. So there are particular type of bacteria, that is prokaryotic bacteria, that has got a large capacity to precipitate the minerals actually. So such bacteria, one of the advantages, it precipitates a lot of minerals, first thing. Second thing is it can survive in a environment where large alkalinity is there, because concrete is basically an alkaline material. So whatever the bacteria that we are going to use, it should survive in such an environment. Otherwise, it will not survive. Okay. But the self-healing concrete has got a lot of applications wherein the cracks gets closed on their own, okay, without the aid of the external repairing mechanism or whatever. These are all the figures which will show you how a normal concrete crack is remaining after a lot of gap, wherein bacterial concrete, the crack is getting closed into the system. Okay. Now, another thing is self-curing concretes. Self-curing concretes. Okay. So, you know that self-curing concretes with polyethylene glycol is there, which will normally helps in internal, avoiding the water evaporation. Avoiding water evaporation. So thereby, whatever the water is added, that is useful for the curing of the self-curing concretes. Like this, the super hydrophobic concrete. Super hydrophobic means for this, the materials that are being suggested, the coatings, manganese, polystyrene, nanocomposites, or precipitated calcium carbonate, CNT structured coatings, nanosilica coating. These are all these certain coatings which will impart the super hydrophobicity on the surfaces of the concrete, maybe. And also the surface modification also can increase the hydrophobicity of the concrete. Lunar materials. Lunar dust has been tested actually. These are the cement properties and flash properties, and lunar dust has got this kind of properties actually. Okay, so these are all the properties. Then, what are the different approaches that are useful in making lunar concretes? One approach they are suggesting is one is a geopolymer concrete, another is sulfur concrete. Okay. So of course, each has got its own advantages and disadvantages are there for this. Sulfur concrete is the one which consisting of sulfur, fine and coarse aggregate, and it contains neither cement nor water. So that's there is no, but it attains the high strength at very early age, 35 MP in 8 hours actually. But disadvantage is it has got a low melting point. So that is another problem. Then vulnerability of combustion. So poor resistance to freezing and thawing. Then corrosive effect on steel and very brittle. These are all the disadvantages which the people are trying to overcome. That's how best we can overcome such disadvantages. So the list of special concretes goes on actually. I'll close it in another 1 or 2 minutes. Okay. So these are all the various types of special concretes, specialized applications. Then in future, one may have to use non-engineered cement, nano-engineered cement, sorry, nano-engineered cements. Okay. Then people are working on DNA of concrete. Okay. You can Google it to find what do you mean by DNA of concrete. MIT has come out with certain findings wherein one can structure the DNA of concrete so that we can assess the future problems that are going to come in concretes. Okay. Then geopolymer concrete. Then this geopolymer concrete, you know that people use the flash and GGBS with alkaline activators. So by mixing of these things, one can have by the process of polymerization, one can produce the concrete. That such concrete is called as a geopolymer concrete. It doesn't require any curing. Okay. It doesn't require water and curing naturally, this thing. So that is why it is one of the materials that is a promising material for future concrete application. Then another is a carbon concrete. Carbon concrete, the idea is from the natural seashells. Natural seashells actually. Natural seashells are there. You know the formation of natural seashells. They seawater contains a lot of magnesium and quantities, lot of quantities of magnesium. Now, coming to the why not we can use such process in developing a carbon concrete. So that is the idea with which this carbon concrete has come in picture actually. Okay. Now coming to the that's why the industry is learning from the nature. Industry is learning from the nature. How the natural binders are being prepared. From that, why not use that kind of a concept to concrete, produce a sustainable concrete and green concrete. Recently, there is one article. Why not we can generate the electricity, thermoelectric cement hydrogel. That is a kind of a electric cement hydrogel composites. So this is one of the article that has been published in Science China Press in April 2025, wherein we can have the production of by keeping the sensors inside the concrete, embedding the sensors, one can produce the electricity also. That helps in the self generation of the electricity of the building itself. So like this, there are a lot of natural technologies are being employed in producing different types of concretes, So that means we are learning from the nature. That's called biomimicry. Okay. So coming to the end, here I have listed certain research scope activities for the benefit of faculty whoever is listening. Okay. So they can think and they can work on these things. One is a self-compacting concrete, mixed design, and its fire resistance, shear strength of self-compacting concrete. These are all the things which require a lot of research. Then self-healing concrete. In that, quantum of healing. Nobody has come out with a quantum of healing actually. So those things we can study. Then a lot of cement alternatives we can see. Then smart concretes. One can work on self-sensing concrete using the CNTs, etc. Then nano-engineered cements. Then the A and ML applications in structural engineering. Then bio-inspired concrete. Okay. Then 3D printed concretes. These are all these certain aspects one can research this. Okay, now coming to the conclusion. So with all these new technologies, we are going to expect some of the special concrete that is a little bit more expensive per cubic meter to buy, but it will require less skill and effort to place, look better, no appearance defects, it will be more durable and require more skill at the batching plant, more greener and sustainable. Okay. So knowledge of small things can create gigantic changes with various economic benefits to the construction industry. Okay. So my slogan is if you care concrete, concrete is a man-made stone after all. If you care concrete, concrete will care you. So know concrete better and care concrete better. So all the best, and this is a small quotation by the great legendary engineer. Okay. Now,
Thank
any questions?
Thank you, sir.
Yeah, thank you.
Thank you for your wonderful quotation and also for your wonderful presentation, sir, on sustainable concrete technologies. Your talk has given us a new perspective on developing smart technologies, eco-friendly and durable construction materials, sir. Now we'll proceed to the interactive question and answer session.
Okay.
Participants who wish to ask questions may kindly unmute themselves, or they can also post their queries in the chat box.
And you can also mail my email ID, of course, you can find it in website, drseishu@nitw.ac.in. You can also post a question by giving a mail also. I'll be happy to answer. Okay.
Sure, sir. Dear participants, if there is any questions, you can post in chat box. Any queries? On behalf of the organizing committee and all participants, I sincerely express our gratitude to Professor Ramsheshu sir for sparing his valuable time and sharing his rich expertise with us today. Sir, one question, sir. Shall I, sir?
Yes, yes, yes. Please.
As per IS, up to which grade of concrete we can use for buildings, sir?
Any grade. Minimum grade they specified. Minimum grade is M20 grade. Above
Okay, sir.
M20 grade, you can use any grade for structural applications. Okay. For non-structural applications, you can use M20 and less.
Okay, sir.
For structural grade, you can use any amount, any grade, depending upon requirement.
Okay, sir. Sir, one more question, sir. What are the possible topics to do research in concrete by using AI, sir?
There are a lot of topics of the AI. Okay.
Okay, sir.
Particularly the what is the purpose of this artificial intelligence or machine learning techniques? See, here I'll take 1 minute actually.
Yes, sir.
First of all, if you look at the development of this AI journey, if you look at the development of journey, first of all, how this technology have been developed. Look at the concrete. In the early stages, we used empirical methods. Actually. By way of empirical methods, we try to develop. Afterwards, we try to formulate the principles using the scientific principles, etc. That means first we observe the system, then we try to model the system by we try to understand the system by way of applying the physics principles of physics, etc. These are all the standard technologies. Then afterwards, with the advantage of computers, what happened is the people are able to analyze the systems in a better way because a lot of computational effect is required in analyzing certain system. That was possible only after the invent of computers. Okay, so that's all. Okay, one aspect of that. With that, what happened is nowadays a lot of data is available already. Then how best we can use the available data. For example, here, just for the benefit of it, I'll just give one small example. Just 1 minute. One example, I'll just give you one small question. Suppose if I want to travel from Warangal to Hyderabad is a 120 kilometers distance. Okay, then if I ask a question, how much of time it will take to my journey if I go in a car? There is a principle is there, distance, time and speed. Okay, so if you go at 40 kilometers per hour, you will reach in 3 hours, something like. There is a standard relations are there between distance by time or distance by speed, you will get the time. This is a time. Okay, this is a physics, whatever it is, relations are there. But now, I don't want to go by such relation. What I'll do is, I have a lot of data in there. What kind of data? There are 1,000 people have traveled on different occasions from Warangal to Hyderabad. Let us take that particular task. Okay. So 1,000 people have got 1,000 experiences, 1,000 different times. They say that if I ask somebody how much time you have taken me, he says that it has taken me 2.5 hours. Somebody says it has taken me 3.5 hours. Somebody may take this 3 hours, something like this. That means 1,000 set of data is there. I don't need to go for distance, time, speed relation. So I can use this 1,000 data, and from that I can interpret how much of time that if I travel it will take. But it looks a little bit confusing. But the thing is, that is what which is happening with the availability of data. How best we suppose if I have a geoformer, if I produce a new concrete shear strength, let us say for normal concrete, if I test and say that this is the shear strength of such a concrete. Suppose such data is already available, where is the need to go for a testing, first of all? There is no need to go for a testing. You have got already literature, there is a lot of data is there on shear strength. Then use that shear strength data. That's why data bank is very, very important for this application of this AI actually. Then what is the authenticity of the data? So when it comes to the concrete research, AI applications are there in many. You take any aspect, concrete shear strength if you take. That means using AI, estimating the predicting the shear strength of concrete. Then you collect all the shear strength data available in various sources. Then try to apply the AI principles and try to come out with a logic or a process wherein process or procedure will give you shear strength. So you can apply to anything. There are a lot of topics of this. There's no limit for that. Okay.
Okay, sir. Sir, one more question, sir.
Yeah.
Can we use kerosene as an alternative liquid to find the specific gravity of cement?
It is the process we are already using now. The kerosene doesn't react with the cement. That's why you are taking that kerosene
sir.
actually. Kerosene. Wow. How to find the specific gravity? Specific gravity, normally any specific gravity is determined using the water. But when you use for cement, there is a reaction takes place, hydration. That's why in place of say high water, we use the kerosene. That's a normal practice only. We can use it.
Okay, sir.
Okay.
On behalf, thank you, sir. Thank you for your wonderful session, sir. It is very useful and very informative.
Thank you. Thank you. So if you
We
have
also
any
thank all.
specific queries, you can mail to me. Okay. We'll have it through
Sure, sir.
interaction. Through interaction only, the knowledge will input. Okay.
Okay, sir.
Thank you.
Thank you, sir. We also thank all participants for their active engagement throughout the session. With this, we conclude the first session of our ACT ATAL Faculty Development Program on Sustainable Practices and Innovative Trends in Civil Engineering. Thank you very much, Ramsheshu, sir.
Yeah, thank you. Thank you all for your patient listening. Okay. Okay, now I am leaving. Thank you. Bye.
Thank you, sir.
Yeah.
Dear participants, welcome to the session 2 of the day 2 of ACTE ATAL Faculty Development Program on Sustainable Practices and Innovative Trends in Civil Engineering. Our next expert session is by Mr. Ramesh Konchada, sir, General Manager at Alterra Solutions LLP, on transforming nation with geospatial innovation. Before we begin the session, I now invite our faculty colleague, Ms. P. Sridevi, Assistant Professor, to formally introduce our eminent speaker to the audience. Over to you, ma'am. Hello, Sridevi, ma'am. Hello, Sri.
Madam, I am audible? Madam, I am audible?
Yes, ma'am.
Hello? Hello?
Yes, ma'am. You're
Audible. Yes, ma'am, audible.
Madam.
Thank you, madam. Okay.
Yes, ma'am.
Good evening. Okay. Thank you, madam. Good evening, everyone. It gives me immense pleasure. Good evening, everyone. It gives me immense pleasure and honor to introduce our eminent guest and today's speaker, Sri Ramesh Kunchada Garu, the General Manager at ALCTE Solutions. Ramesh sir has 33 years experience in the field of civil engineering, which includes 8 years in project management, project planning, contract management, coordinating with structural designers and architecture for multi-storied buildings, drinking water supply projects and road projects, 25 years in field of surveying and the geospatial industry. Sir Ramesh Garu obtained B.Tech in Civil Engineering from Jawaharlal Nehru Technological University. He had done a certificate course in GIS and remote sensing from National Remote Sensing Center, Hyderabad. Ramesh Kunchada Garu has worked extensively with advanced survey instruments such as DGPS, drones, and total stations. His professional journey includes visited survey instruments manufactures factories at Shanghai, China, and Tokyo, Japan, and representing India at major international platforms such as in Intergeo in Germany, India Geospatial World Forum, and UN World Geospatial International Conference. Ramesh sir also serves as a guest faculty member for prestigious engineering colleges across Andhra Pradesh and Telangana, and for institutions such as the Geological Survey of India and the Engineering Staff College of India, where he delivers lectures and field demonstrations on drones, DGPS, total stations, and advanced survey technologies. We truly honored to have Sri Ramesh Kunchada Garu with us today to share his vast experience and invaluable insights into the field of civil engineering and geospatial technology. Over to you, madam. Hello. Over to Ramya, madam.
Ma'am, yes, ma'am. Thank you, ma'am.
Thank you, madam.
Hello, sir.
Yes, madam. Good evening.
Uh,
Madam, I am audible?
yes, sir, you're audible, sir. Sir, we are delighted to have you here, sir, and look forward to your talk, sir. Over to you, sir.
Okay. Good evening and welcome to all the participants in the seminar. I feel it is a great privilege for me today to have this session in front of all your dignitaries and experts from civil engineering, different specializations. Today, I will share you how the technology in surveying and geospatial field has changed from chain and tape to the lidars and drones, as on today we are most popularly listening about. So, for any civil engineering project, the first basic requirement is the field data. The field data is collected by a survey engineer, survey crew consisting of team, and this team collects the data from the field and they provide the data to the design and planning teams. This is very crucial to have a proper layout of any factory or any society or any public enterprise buildings or commercial buildings, to have a proper planning for all these kind of structures, drainage systems and different kind of establishments in the layout. So we are going to discuss now about the surveying right from the chain and tape to the lidar and drones. Madam, can you please present this?
Sir, shall I share your screen, sir? Shall I share your presentation, sir?
Yeah, please share that.
Or will you share your presentation, sir?
Yeah, you please share that presentation.
Okay, sir. Just one minute, sir. I'm
Okay.
sharing your presentation.
Shall I share, madam? Otherwise?
Sir, you can share your PPT, sir.
Okay.
If there is any network issue, then I'll share, sir.
Sure, sure.
Actually, thank you, sir.
Is my presentation visible, ma'am?
Yes, sir. Yes, sir. Visible, sir.
Yeah, thank you. Thank you very much. Now, today agenda is consisting of history of surveying, then about GNSS, then terrestrial scanners and BIM integration in that surveying, then mobile mapping system and its applications in asset management and 3D modeling. Next, handheld scanners and its application that is called as SLAM, application for 3D modeling, and drone surveying and generation of 3D models. First, if you see the history of survey, in olden days, people used to measure the distance between two destinations manually by estimation. So much of fields or so many this thing and all. Then the linear measurement devices like chains came into use to measure the linear measurements and cross staffs to erect right angles. To measure an area boundary, a boundary, chains and cross staffs are being used by the people in olden days, even till before last 10 days, last 10 years. All these village boundaries, agricultural lands are being used, measured by local survey team, by revenue department, using a cross staff and a chain. The disadvantage of these two equipments are this chain will be having 20 or 30 links depending upon the length of chain, whether it is 20 meters or 30 meters. Each link is consisting of 20 centimeters. If someone is not regularly checking the length of the chain, if some links are missed and somebody has joined the chain by removing the rings, you will get error. The actual measurement is less than the value measured in that case. And also the chain and the chains are having a metal body. There is always chance of sagging, and the link between the link sagging in the link sagging in the so many other metallic parameters also. Also, if you want to measure a long length around thousands of hundreds of kilometers or at least 5 to 10 kilometers using a 20 to 30 meter chain, it will take a lot of time, and also during the obstructions and all, crossing the obstructions and all, different kind of survey methods like offset method, all these methods we need to follow. Then the linear measurement after the chain, measuring tapes are introduced. So measuring tapes are accuracy wise, least count wise, okay, the accuracy is improved up to 1 centimeter, and in the steel tapes, short length tapes of 5 meters and 3 meters, up to 1 millimeter, least count we are getting. But again, the limitation in measuring with a chain is although I'll say as the same as like a chain, because even chain measuring tape also having a length of maximum 30 to 50 meters. After 50 meters, again we have to shift the point and we have to take multiple tape lengths to measure a distance in kilometers. This may cause some manual errors, instrumental error, and the accuracy of the final measurement or the linear measurement will be very not that accurate as on the ground. Coming to the angular measurement distance system, the cross staff will give us the angular reading up to 90 degrees least count. So we can erect a right angle using a cross staff, but any measurement, angular measurement in between 0 to 90 degrees or 90 to 180 degrees, it is very difficult to measure with a cross staff. It is not possible to measure with a cross staff. So then to improve the accuracy of the linear measurements, the system has come like in on every surveying instrument in auto level and theodolites. There is a method called as Stadia hair method has come up in the manufacturing systems. The stadia measure is nothing but in every surveying instrument, if we observe for total, particularly for auto level and theodolite, there will be upper stadia here and lower stadia here. The constant of the stadia constant of every surveying instrument as a universal factor is it is 1:100. That means if we measure, take a reading of upper stadia here and lower stadia here, the difference of that reading will be 1 meter at a horizontal distance of 100 meters. So by interpolating that 1:100, that 100 in 100, 1 meter in 100 meters, whatever the difference it comes here with the upper and lower scanner, if it is 5.5 meters, 0.5 into 100, that is 50 meters is the distance. Like that, we are able to improve the accuracy of the horizontal measurement, but at the same time, the visibility is the concern here. Even in this case, using a theodolite or auto level, we cannot measure a distance of more than 50 meters or so in good weather conditions like early mornings or late evening. In the afternoons, even it is not possible up to 50 meters also to take a reading in clear cut reading by up to a 5 millimeter accuracy using a surveying instrument with stadia hair method. Then the next development is to measure the horizontal distance, EDMs, electronic distance measurement units. So electronic distance measurement units are introduced in late 80s and 80s. The unit is mounted on top of a theodolite. A battery power will be there. So linear measurement will be taken by electronic theodolite. EDMs, and angular measurement with the electronic theodolite or a micro-optic theodolite or a vernier theodolite. Here in this case, this EDM gives us the horizontal vertical slope distance. So using the vertical angle, and we have to convert that horizontal slope distance to horizontal distance by using the trigonometrical formulas. So also there will be an offset between the axis of the theodolite and axis of the EDM instrument also. So all these parameters we have to take into consideration and prepare a chart and apply these corrections and convert those slope distance to horizontal distance and apply these offsets, and all these manual calculations will be there, and ultimately after doing all these manual calculations we will get the exact line from one point to the other point with respect to the actual distance. Then the next advanced surveying instrument is the total station. Total station is a combination of electronic theodolite and electronic distance measurement unit, EDM. The function of electronic theodolite, it measures the horizontal and vertical angle, both slope, and the EDM measures the slope distance. So once the EDM measures the slope distance and electronic theodolite the horizontal and vertical angles, the data will be connected to a microprocessor inbuilt in the total station. The microprocessor is having certain kind of standard trigonometrical formulas and coordinate geometry formulas. The microprocessor will apply the correction formulas to the readings, and it will always display the horizontal distance on the screen of the total station. Not only horizontal distance, in olden days, all the measurements are with angle and distance. That is, we used to measure the distance and then the angle, then plot the drawing using a angular measurement device and a linear measurement device like scale and protractor. But after these total stations are introduced and the technology has developed, the positioning system, 2D positioning system is changed from angle measurement distance system to Cartesian coordinates. That means X and Y coordinate system. The coordinate system is nothing but from the horizontal angle and horizontal distance, we use the coordinate geometry formula x cos theta, y sin theta, x1 plus cos theta plus y1 plus sin theta to derive the coordinates of the next point. So that formula is also included in this total station microprocessor. The microprocessor, if you go into the measurement mode and if you say this coordinate system, it will ask to input the station point coordinate. That means in a graph sheet, we are defining where the origin is and where the x-axis and where the y-axis. Once you define all these points, then after that, when you are measuring a point with a prism, the prism is a cuboidal glass one which reflects the light. So total station, when you focus the total station to the prism and say measure, the total station sends a laser beam, and the laser beam goes and hits that glass prism, and it comes back, reflects back. The EDM machine inside the prism, inside the total station, will receive the signal back, and depending upon the velocity difference of the signal, light beam, it calculates the distance from instrument to the prism place where the prism is taken place. So using that slope distance, again the same formula, it calculates the x and y coordinates, and it saves in the memory inside the total station. Since there is no manual interpretation here, all the distance and angles are being measured by the instrument, and the final results is being stored in the system, and in the system means in the total station. The manual interpretation is very minimal here, only setting the instrument and giving the right feedback of the existing station point coordinate and the orientation angle. Once this is done properly, everything will be taken care by the instrument, and the data will be accurate up to the millimeter and up to few millimeters, 1 or 2 millimeters, and then the data can be transferred into a software, drawing software like AutoCAD or 3D or Auto Plotter, whatever the software we are using to generate a 3D drawing and 2D drawing, as well as to develop a layout. Once the layout is developed in the CAD drawing, we will take the layout into the instrument. Again, the instrument is having a feature called as coordinate stackout. That means first we have taken the boundary. So once the boundary was measured and all the boundary was given to the consultant and planning department, they will plan the internal roads, buildings, drainage systems, and other things. And each and every point will have a x and y coordinates. Like in this case, if you go to any particular point, there will be an x value and there will be a y coordinate value, or there will be a north coordinate value, y coordinate value. If you know this coordinates and input these coordinates, and once the building construction starts, we have to locate where the building is exactly coming. That means that is called a stack out, or location of a point from drawing on the ground. That is called a stack out. Again, the total station, we will feed the coordinate of required point. If suppose I want to mark this point on the ground, we will input this x and y coordinate, and this coordinate is already fed to the instrument. Instrument will calculate the bearing to this point. That is again depending upon the formula of tan inverse y2 minus y1 by x2 minus x1 square. And once the angle is derived, the instrument will ask the surveyor to turn your telescope to that particular angle. Nowadays in advanced total stations, the total station itself turns and locks to that angle. That is called as robotic technology. And once the total station angle is fixed, surveyor will ask the person to hold the prism on that direction. So he holds the prism in this direction. So after measuring, the instrument will say this point is, if he is by mistake, because he is holding the point at approximately 10 meters, means here and here. So he says if it is here, you move back few centimeters. If here, you move back few centimeters forward. Once he reaches this point, if say your deviation is 0, 0, this is your point. Like that, using a total station, we can do the survey for building construction, pipe, any kind of area which is less within visibility because visibility is required here. Whereas nowadays in cross-country pipeline surveys, like we are doing project work, water supply projects from one barrage to the nearest other areas, and also if you see from Yanam to Gujarat, the pipeline was laid. That is all cross-country pipeline. So using a total station for marking those kind of long cross-country pipelines and use construction activities like national highways and state highways and all. Every time we have to shift the emission, because total station having limitation, it has to have a line of sight between the prism and the instrument. If prism and instrument are not in line of sight, we have to change the instrument. That means shift the instrument onto the next station control point, again backside and orient to the previous station point to get the same orientation and same grid line, grid, then go forward. It takes a lot of time and consumes a lot of manpower also. To avoid this, the next equipment came into the surveying field is global positioning system. Actually, what is GPS? Now, because total stations are nowadays limited only for the marking of building construction lines, central lines, and bridge lines. But nowadays, the vast and very advanced surveying instrument for all these equipment, GIS projects implemented by Survey of India, Department of Land Resources, or Municipal Administration Department for Naksha. Whatever the survey they are doing, either it is a drone-based survey or a LiDAR-based survey, the basic instrument to get the coordinates is GPS. The CPS is a radio navigation system. It was first designed and developed by US Department of Defense for their military applications. Because why the military application is required this equipment by US department is those days when their US departments are US Department of Defense, that means US Army forces are deployed to other countries. There is no local idea. I don't no idea for them how to move from one place to other place in an unknown territory. They used to depend up mostly on the local information system by otherwise local people or local supporters who are supporting them. Sometimes they are misguided and they are in trouble. To avoid this kind of situation, they thought and they developed a navigation system for their military application. It is a super accurate system with position accuracy from meters to millimeters, because there are a lot of difference there in different kind of GPS equipments are there. In our mobile also we have GPS, and for boundary survey also we are using GPS. So this mobile application GPS gives an accuracy in meter, and our survey for the land application and all, it gives an accuracy in millimeters. Depending upon the accuracy, we will choose the equipment. This gives a position information in 3 dimensions. It gives horizontal X and Y or northing and easting position, as well as third dimension with respect to the mean sea level, how high our location is. These signals are free. GPS signals are free. Everybody on earth can use without paying any fee. Unlimited users. There is no limitation of users to use the GPS. It is it is transmitted from the satellites from the sky, and unlimited users on the earth can use without any congestion of the signal. Round the clock availability. GPS signals are available round the clock. It was designed in such a way from anywhere on the earth, at any location, at any point of time, 24 hours, 360 degrees, GPS satellite signals are available. The GPS system was designed to replace the large variety of navigation system, as we thought initially. In olden days, using stars in the night, they used to travel. After that, compass, using the compass, they used to travel. The compass is also a magnetic compass, having it gives some errors because of the local attractions and local attraction. So those kind of all world navigation systems are replaced with GPS with latest technology. Why GPS is the GPS system, GPS coordinate system is unique coordinate system. That means generally GPS gives altitude and longitude values. The latitude and longitude measured in one point will not repeat at other place at any point on the surface of the earth. The coordinate system is one look unique. If you give one value, latitude, longitude to a person to come and reach here, there is 100% he will come and reach to that point only. There won't be any another repetition. This is world coordinate system. The coordinate system is designed considering the world as a one unit. Though some geoid models are there for getting third part arithmetic heights, that's called elevation from above the mean sea level or close to mean sea level. Projections of the world, because projection, what is the projection means? GPS, a raw GPS will give us the projection in W84 datum. The latest datum is WGS84 will say. That means latitude, longitude with reference to WGS84 datum, which was designed by the GPS community. But some applications like defense and all, they use their own grid system, because in defense they don't use coordinate system used by civilians. They have their own coordinate system, because that system they wanted to keep it secret, only known by the defense people with their knowledge. So like that, we have some other system, Indian geodetic system also available with in India. But nowadays all the Survey India maps and everything is WS84 datum converted into WS84 datum, except for the defense application. That is not for the civilians, but all civilian users are using WS84 datum, and Government of India also, for all the applications, it is giving public data in WS84 datum. So coming to the GPS satellites, there are initially US was invented the GPS system. They named it as a Navstar. After that, slowly one by one, Russians, Europeans, Chinese, Japanese, even now India is also into that community. So Russian system is called as GLONASS. European is called as Galileo. Chinese system is called as BeiDou. Japanese system is QZSS, they named it, and the Indian system is IRNSS. The top four, Navstar, GLONASS, Galileo, and BeiDou, are the global satellite systems. That means these satellites, these people, Europeans, USA satellites, can be viewed from anywhere on the world. So these satellite systems covers the entire globe. Whereas QZSS and IRNSS, Japanese and Indian ones, are called as regional satellite systems. Regional satellite system means there are 5 satellites for India. These 5 satellites only focus on India and its subcontinent, surrounding countries. These satellites move across along with the globe, focusing only on the Indian subcontinent in these neighboring countries, like Japanese also. Whereas the other 4 satellite system, the satellites will continuously rotate around the globe, and it covers the total at Earth, and it gives the coordinates to anyone on the Earth from all the locations around the Earth. So how the GPS is giving the coordinates and what the principle it is working on is that it is nothing but trilateralization. Suppose if you see this plane table surveying, 2-point problem, 3-point problem, what we will do? We have 3 ranging poles fixed at location, known location. Our plane table is at an unknown location. We will measure the distance from the ranging rod to the plumb bob of the plane tone. Then we will convert the distance onto the drawing sheet, and we will draw the 2D arcs or 2D with the same radius. We will draw the 2D circle. The common intersection point where all the circles meets is the plane table location, and we will say this is my plane table location. Even using that kind of technology in olden days, we used to draw the locate the locations of the different features on the boundary on a plane table. Same technology, but it is not a 2D, it is a globe. It is a globe technology. It measures the total the area, the distance from the satellite to the global receiver on the Earth, and by measuring the distance, it draws a circle. The common intersection point of the 4 circles will be only one, and that one point will be the position of a GPS receiver on the ground, and that position will be calculated by that software inside the receiver, and the software will give us the latitude and the longitude of that particular location. So we are talking about GPS coordinates, and these coordinates are global coordinates and unique coordinates. It will not repeat it anywhere. So what is the reference system of that? The system is, for this purpose, scientists have considered the Earth as an ellipsoid. Actually, Earth is not a exact circle or a perfect ellipse. It is close. The shape of the Earth is very close to ellipsoid. So they converted that to a model, best fit model. They designed one ellipsoid, and the ellipsoid, the semi-major axis and semi-minor axis will be there. Intersection of the semi-major and semi-minor axis is taken as the origin for GPS coordinate system. That's why the entire globe is like this. So the center point is the common intersection point is the origin for GPS. If you are anywhere on the Earth, here the angle perpendicular to the latitude is the semi-lateral, parallel to the latitude, like this one is the longitude. So if you see this angle and this angle, latitude and longitude, at any point of time, any point if you take on the surface of the Earth, it will be a different value, because it is in 360 degrees, it gives a different value. It never repeat. If the values are never be repeated anywhere on the Earth, surface of the Earth. So this is the major concept while designing the DGPS system. They have taken a model, and the model they have taken that intersection point of the semi-major and semi-minor axis as the origin for the GPS, and parallel to the ellipsoid and perpendicular to the ellipsoid, they are given as the latitude and longitude. Then what about the height? Because this is a model, ellipsoid is a model. It is not on the surface. It is not a real Earth. The surface is not available in the Earth. So how it is giving the third dimension? XY, okay, latitude, longitude. How the third dimension is coming now? The third dimension is called as the orthometric height. The orthometric height of this GPS coordinate system is derived from this ellipsoidal measured surface and the geopotentiality difference of the geopotentiality of the Earth above or below the assumed surface. So this ellipsoid is the dotted line. This green line is the about exact actual surface of the Earth. So this difference is calculated by using a geoidal undulation. We will call this difference as a geoidal undulation. The geoidal undulation is nothing but the geopotentiality of the Earth. So the GSI, the NGRI and all these communities all over the world will calculate the geopotentiality of the Earth with respect to the estimated assumed geosurface for each latitude and longitude position, and this geodal value will be applied to the ellipsoidal value. So orthometric means the actual surface height, orthometric height will call as. Orthometric height is ellipsoidal height plus or minus the geodal undulation. So this geodal undulation, maybe in valleys it is low, in some areas it is high. So this, depending upon the latitude and longitude, that position, the geode model will find out what is the geode separation there, that is called a geode separation. That correction will be applied. That's why actually GPS will not give exact MSL. These values are almost a little bit close to the MSL, but it is not actual a MSL. So GPS heights in the northing easting is called as orthometric heights, and raw GPS height along with the latitude longitude is called as ellipsoidal height. So they are coming to the DGPS. What is DGPS? Differential Global Positioning System. Differential Global Positioning System, why differential global system we require is, generally in any GPS system, whether it is high-end GPS or low-end GPS, even though the GPS is a survey grade GPS also, if you switch on the receiver, we will get an accuracy of plus or minus 1 to 1.5 meters or 2 meters accuracy. But we in our land applications, survey applications, 1 meters is okay for the navigational purpose and other mapping and all okay, large scale mapping and all okay. But survey grade for measuring the agricultural boundaries, construction site, and for having this Naksha project measuring the buildings and all, we need accuracy in millimeters. So using the differential correction from base to the rover, we will improve the accuracy of rover position up to a centimeter or 3 to 4 millimeters. This technology is called as differential global positioning system. So why it is differential global positioning? How we will do that is, we will set the mission DGPS base station we will call as, and next one is called as a rover. This base station is, we will set it on top of a known coordinate derived by scientific methods. How the scientific methods is, in olden days up to 72 hours, Survey of India or other agencies used to collect the data, raw data that we call from the GPS. The data will be saved and then it will be processed in some advanced softwares to minimize the errors. What are the errors and why we are getting the errors in GPS is, GPS satellites are in the sky at around 20,000 kilometers above from the surface of the Earth. So these satellites are traveling from space to the ground by passing through two different ionospheric and tropospheric conditions. So GPS satellite signals are traveling at a speed of light, 22,90,000 kilometers per hour, speed of light. But this 22,500 this speed of light. How the GPS is calculating the distance, because it is also calculating distance from the satellite to the receiver, and using the distance it is drawing a circle, and from minimum 4 to 5 satellites, the common intersection point it is calculating, finding, and it is giving the coordinates. From of the light, the signal it is traveling at the speed of light from a space of around 20,000 kilometers away from the surface. What will be the accuracy of that measurement speed required by the rover? Because here GPS receiver is calculating the speed here. So for this, the satellites are transmitting the signal with a code called a pseudo random code, and that pseudo random code is having a time tag from the satellite, which is atomic clock. 10 is a very stable and accurate clock up to 10 to the power of minus 13 seconds. Whereas this receiver is also having atomic clock, but atomic clock is not so accurate as this receiver is having a quartz clock. This quartz clock is not as accurate as the atomic clock. There is a technology called the synchronization of clock. This clock will be synchronized to the atomic clock accuracy by some methods. Then the accurate distance nearest to the millimeters will be calculated. Even though it is doing all those kind of developments and all, software and taking care of all those kind of calculations and all, but there will be some delay because of this tropospheric atmospheric conditions all. So because of all those things, there will be an error of 1 to 1.5 meters. But if you observe the reading at up to 72 hours and then process with the third party software, the atmospheric and tropospheric delays can be removed, can be filtered, and we will get an accurate reading up to some centimeters for this control point. Once the base station is fixed on top of the control point, and while configuring this base station, the software will ask us what is the coordinate of this base station. We will input the coordinate of the base station. Then satellite is giving the signal. This base station is calculating its position, current position from the satellite. So this base station knows what is its accurate value and what is its current value. The software inside the algorithm inside the base station will say this is able to calculate the error. Then the error will be transmitted either through GSM or through a radio modem. Then the rover will receive that error correction and applies that correction to its correct reading, like this base station is directly taking, is also directly taking. And with respect to the base station, it will give an accuracy of 1 centimeter. That is called as differential correction and differential relative correction from the base station to the rover. So in olden days, we used to have one base station, one rover. Nowadays, the technology has improved. Survey of India has, and the government of Andhra Pradesh also, they established their own base station. That is core stations, a network of base stations. Using those network of base stations, the accuracy is improved a lot, and people are getting without base station an accuracy of 1 to 3 centimeters. So this is how the GPS technology has developed right from the navigation application to the survey application. Now into defense also, all these missiles, aeroplanes, this nowadays the drones, every object which is flying in the air and hitting the target, or we are measuring the land boundaries, because if you take a measurement with the GPS, the coordinate is universal coordinate. If you put it on a Google map, you will get exactly the location on the map where you are measured the point. Whereas a total station, we are assuming some coordinate. We are creating our own X and Y system. If you 2 to 3 instruments are there, if everybody is assumed his own system, the data cannot be matched together. Whereas in DPS system, if 10 crew has done the survey, all the data can be integrated on the same platform, because the coordinate system is unique coordinate system. This is how the GPS technology nowadays changed the survey, geospatial industry, complete this thing. And now every survey, whether it is a drone survey or it is a LiDAR survey or it is a scanning survey, is based on the GPS coordinate system only. Now coming to this application, coming to the building construction and all. See, in olden days, we used to have only 2D maps, 2D drawings, plans and all. So using the 2D plan, we'll fix the column position. Then we will see where is the locations and all. Even doors and windows also represented in the drawing on a paper with a 2D on a 2D paper, 2D surface. But nowadays the system has improved. There is technology called as BIM modeling, and there is a 3D modeling also they are developing. Now, this is a classic example of our Parliament House construction when it was under construction. This is the one type of scanner. So, what this model will do is that, this scanner will do is that, yes, this model is developed on the empty land. The land was surveyed with a total station or DGPS, but the coordination system was global coordinate system. So this scanner is kept on at one convenient place and they scan the entire construction progress. So this, what is the application of this scanner is, the scanner will collect the data will go to the post processing, and the office software that there is some softwares called as RealWorks or some TVs and all. The office software will check whether the construction activity is progressing according to the 3D model designed by the consultant or there is any deviation. I will show you some examples. It is a ILRS based range measuring system. It can be used for mining application, beam application, and it is a completely high integrated instrument which is sophisticated software tool addressing the need of users. This terrestrial scanner, this is called as a terrestrial scanner, can be deployed by a single operator. There is no need of multiple screw, only one can do the survey. Setup is rapid and simple. The target area is scans to start and display will be located on the screen. These terrestrial scanners are designed to measure the objects in front of it only with light beam theory. Like total station is one shot, here it will take continuously keep on sending the laser beam, and the laser beam will keep on giving the readings, and it will be saved in the computer inside the memory unit of the system. There will be a rotation, it will automatically rotate 360 degrees horizontal and 300 degree vertical and continuously keep on scanning. And there was a camera also inbuilt in the receiver. The camera will take the photographs, and it can be, this camera photographs also can be georeference, and it will give us the scanning image with photography on the background. This is a different kind of specifications it is. This is the application of the terrestrial scanner. Now, if you can see, there is a concrete pouring happening. Generally, what happens if it is a raft concrete and all, okay, there is undulation, doesn't much affect. But if it is a flooring concrete, we need to check the levels also, because once the flooring concrete has laid, if the flooring is a certain slope towards some northeast corner or other corner, so while pouring the concrete itself, we used to use to maintain that slope. Previously, it was done with a auto level, but auto level is having its limitation up to 5 millimeters and all. Whereas using this concrete scanner while pouring the concrete, we can see the heat diagram of the surface. Now see, there is heat diagram. All red marks are okay. It is under that tolerance limit. Some patches of the concrete work is marked with some yellow color. So once this can be displayed on the screen of the scanner in the site while doing the scanning itself. So immediately the survey crew member or survey engineer will inform to that person who is in charge for the concreting. He will directly go to that particular location, and they will, when the concrete, before the concrete was set, concrete was in wet condition, they will do the rectification that will make the concrete surface as per the design slopes. And also one more key point, suppose this is once after removing the scaffolding, this is the bottom of a slab with beam and beam layout. We have a 3D beam model. Whether this beam model was followed or is there any deviation? Now I am scanning this entire slab and scan this one as an entire slab and columns along with the beams. Now we can manage the layer. By removing the layer of this beams and slab, we check the column positioning. So here the different colors are there. These different colors are the scan data. And now you can see, different color scan data. And inside that, the BIM model is also there. If there is any deviation here, it will automatically reflect. If you see the next scanning here, now this is my column. These blue lines are upcoming structural components. Now see my column, whether this is exactly laid as per the design to fit my structural component which was prefabricated at some location and coming here with all the prefixed dimensions or not, I can easily mention. So this Other models, this model is blue color ones are the model from the model, and the other scan data is my original data. So these two are exactly flashing together. That means tomorrow if this component comes here, and this can be easily fit into this without any deviation, that can be checked before the erection is started. Suppose if it is a steel structure, otherwise the steel, if you see these airports and all nowadays coming with different kind of purlins and all, these things will be fabricated in the site. So before the fabrication happens here, they will scan the data in the workshop, the main workshop, and they will bring that to the site, and before assembling they will check all these parameters, and if there is any deviation in the fabrication, previous fabrication or the fabricated item, they will correct it immediately, and before erecting it, they will do the necessary rectification. And also main thing is in the building construction, MEP, mechanical, electrical and plumbing lines. Generally the conflict comes with the electrical, plumbing and mechanical works, because this structural engineer goes as per his plan, but sometimes it clash with the plumbing lines, electrical lines. So to eliminate that, while doing that structural engineering, once the columns were laid, we can easily check these points, whether there is some point is coming here, we don't know what is that exactly, but there is some important object is coming here. So using this instrument, give that equipment, it will point out that, see, exactly it is pointing towards the corner. Whereas it is like this, exactly pointing to the location, pointing to the corner. Now see, this C5 is the board center point. Actually, it is supposed to come here, but the position is shifted here. Why? Because either in the model, either somebody has made a mistake, and instead of doing it here, they might have given the position here. So this has to be rectified. That's why before the plumbing line or some electrical line is layout is starting, work is getting started. So these people will go, they will take that BIM model and they will switch off all the layer, and they'll switch on only the layer which is required to check, which they wanted to check, and they will check the points from the drawing directly in the field. There is no need of any converting those drawings into coordinates for X, Y, Z coordinates. From the model itself, we directly will get the coordinates, and if we click some point and check where it is instead of showing it here, it was shown here. So immediately it will be communicated to the design team and planning team. They will now rectify, they will modify it, and they will send them the revised drawing, the 3D model, and then the revised 3D model will be used for layout of this building components. So here also there are some components they are checking here, here and here. So it is perfectly matching. It is coming to the location, but here it is going to the edge, because these are all the conflicts they are detected before the work was started. Now this is again we are coming to this columns and beams layer. Now once the scan is completed, we can see the scan surface like this, columns here, beams here. This is all 3D point cloud data. So using this 3D point cloud data, now we can see if there is any deviation, if there is in the columns and beams, if there is whether they are vertical or whether they are truly straight or not, we can check it in this. Coming to mining industry also, this scanning data is giving a lot of advantage to mining industry particularly, because this mining industry in olden days they used to calculate the volumes by theodolite using the tachometry method, but they are not able to cover everything. Even after the total station have come, even the total station also, they used to use the total station, but they are not able to measure each and every point on the surface of the mining pit. So once the scanner has come, scanner is with such an instrument, it takes minimum 26,000 points from second to the 1 lakh points also, depending upon the scanner specification. Each and every point on the surface of the mine pit will be measured, and the volume exact up to the 0.02% variation they are now able to achieve, and the volumetric analysis and the building system was improved a lot to get the actual quantity of measurement in the large open cast minings. Now you see here the scan data. The scan data is covered each and every part of the scanner. Whereas if you are using a total station, we can use a total station. One person has to go with the prism. He has to hold the prism there. Next, he has to move to the next point. If that point is accessible and say on safety grounds, it is okay, he will go there. Otherwise, he will miss that point. But whereas in the scanner, by standing at around a half kilometer or 1 kilometer, that entire mine surface we can scan and we can digitalize it a 3D model. So this is actual 3D pit. If you see with a scanner, it is actual 3D one mine. It was scanned from 1, 2, 3, 4, 5 location, 4 locations, and a complete 3D map of this scanning mining pit was made, and they are able to get what is the exact quantity of volume excavated from this mine as on date. And also using this mobile mapping system, there is another equipment called as mobile mapping system. So this is mobile mapping system. Using a mobile mapping system, this kind of surveys along the road, along the existing railway track, or there is a road already, one single load is there. The government NHI is trying to planning to expand it and make it a 4-lane road. So by that time, if you are doing a total station survey, we will to get the actual entire site condition in a 3D map is not possible with total station. Now you see in this left side diagram with this black and white point cloud data, so we are able to see what is the hill and how much is the quantity and how much we have to cut. Similarly, if it is going through a built up area, like a village or small town and all, how many buildings are there? What is the dimension of the building, height of the building, length of the building, and width of the building up to some extent, because width comes under the other side. So complete breadth and height of the building, the scanner will take with a 3D map. So this scanner is also called as mobile mapping system. It will be mounted. This mobile mapping system is a mapping device mounted on a moving vehicles. It consists of a LiDAR, like a scanner, like what we are discussing, static scanner, to capture the point clouds from a mounted arrangement on a moving vehicle, and a GPS system, GNSS system, to measure the position of every moment when the car is moving at 40 kilometers or 30 kilometers speed. For every second, it will calculate the position. And then IMU, initial measurement unit, because now in the case of a static scanner, terrestrial scanner, the scanner was fixed on top of a stand, tripod. It was rigid. There is no movement for that. So accurate measurements it will take. Whereas on top of a vehicle, when the vehicle is moving, even scanner is also having some pitch and roll. To compensate that pitch and roll, one IMU, initial measurement unit, will be mounted to the total assembly. And the duty of the initial measurement unit is to calculate how much is the pitch and roll it is for every second. That also, all this data, the scan data, the IMU data, and the GNS data will be connected to a system inside the mobile mapping system. And all this mobile mapping system is also having a camera on top of it. This is a spiral camera, ladybug camera they will call. This spiral camera will be having 4 cameras on all the 4 sides. These spiral cameras will take the photographs of the surface when we are going along with the vehicle, and the 3D photograph along with point cloud data will be created, and the evaluation that planning team and design team will take this data and analyze the data in the office itself instead of coming to the site. And then his doubt is that they will come to the site, they evaluate the data, and they will do the accurate estimates of the project with this accurate data. Nowadays, with railways also, for high-speed rails and all, Indian Railways is doing this kind of survey on the existing tracks to know what are the so along the track, what is the objects on the either side. If train moves at 100 kilometers, 200 kilometers speed, what will be the impact of that speed on the neighboring habitation? So these kind of instruments are available. This is the instrument. This is mounted like roof track, scanner, a GNSS system, and a distance measurement unit also will be there. And inside vehicle, battery will be there for power supply, control unit will be there, data power unit to the LAN connection and all for getting the signals inside that. This is a mobile mapping system. This is widely used for highways and railways application. System is configuring different kind of scanners and all. This is the specifications of the. This is the scanner and this is the top one is the Lerigipa camera. Depending upon the requirement, somebody will use the single head scanner, somebody will use the dual head scanners. So dual scanner means data will be multiple times. Single head scanner means one time it is. So these are the data collected from a scanner. So now this is the data collected by the scanner. This is the photogrammetry image, and this they can easily check the cracks, find out the cracks and other on the road surface. See, this is the photogrammetric. This is the point cloud data. So the total entire road along the road alignment, what are the structures and what are all the tree, what are all the habitation trees and all can be easily counted and it can be used for the estimation purpose. So this is the building scanning data. A bridge was scanned by this equipment, and it was created a 3D diagram for further analysis. This is the point cloud, how it looks. So this is also point cloud because this is a 3D diagram. We can rotate it in any direction to visualize and generate. Nowadays, with the software, post-processing softwares are coming up with advanced technologies. So if I don't want to see the trees, if I select these components and say remove it, it will filter all these trees and it will give me only the road surface. I wanted to see only the electrical poles. If I say only filter electrical poles, give me the view of only electrical poles by giving some commands here. It will filter and remove all these other components and it will give me the only electrical poles like the road crossings, road signs, and all these things can be viewed, filtered, and can be updated in the software. So this is also the same data from the mobile mapping system. Even in tunnels also, even sometimes the scanners are nowadays being used in the tunnels also. Nowadays widely they are using. Before the tunnel excavation is being done by manual methods by just measuring with the theodolite the angle they are used to fix, and blasting team will go and do the blastings. So now with the scanning, they will create a template of the tunnel. The template will be loaded in the instrument. Once the measurement is done, the scanning is done, the template software in the instrument will compare what is the template and how much is overcut and how much is the undercut. So for next blasting, the engineering team will plan accordingly and do the blasting and use the proper quantity of blasting material to get the utmost blasting surface so that the concrete lining will be minimized. You can extract features. What are the features? If you want to see only rails, see this is the scanning of a railroad. You can extract the features. If you want only rail, you just click that button. All the rails will be exported, and you can export into a DXF format in AutoCAD and all to do the further analysis. So what is the clear head clearance of this particular bridge from the rail? If something is coming up, the new thing, kind of any engine is coming, then you need to know what is the clearance here. So from this drawing itself, without going to the site, we can easily measure the distance height between this current surface and bottom of the bridge. So these are all the lines drawn automatically. You can use it using the algorithm in the software. We can automatically join the lines, and those lines can be exported into DXF format so that further designs and drawings can be done in the DX. That is a mobile mapping system, and this is the handheld scanners. Nowadays, for congested areas in any town or village like Bombay, Dharavi, and all, so going inside with a mobile mapping system and taking the readings is very, very difficult. Also, a statistical scanner, number of times it has to be shifted. So for that kind of purpose, they are using this kind of backpack system that is called as SLAM technology, handheld GPS scanner. This is also a scanner. There will be GPS inside the scanner. On top of the scanner, there will be an antenna here. So by keeping the scanner on backside, and we will be moving, one person will be moving around the roads. So whatever is the surface visible to the scanner, all the 3D point cloud data will be recorded, and further analysis like that mobile mapping system can be done in office. Since this is can be mobile system, the mobile mapping system is for long surveys, cross-country surveys like highways, railways, and all. This is for habitation, buildings, inside the building, all those kind of things. This is useful for now. So this is handheld scanner consists of all those things with different kind of components. It is also having one GPS. Calibration is necessary. Every workspace stays and all. Also, we can go up and collect the data from first floor, second floor, third floor as per the construction site. And stock and dust proof can be even for the can be done. Tunneling inside the tunnel also we can do the scanning it here. It is also available 360 degrees panoramic camera, colored point clouds. So camera will collect the will take the photographs, and point clouds will be overlapped on the camera images, panoramic images. We'll get a clear cut 3D color image with point cloud data. It can be used for volumetric analysis also. The street survey up to some small streets can be done with it here. 3D modeling, indoor mapping. Nowadays, this indoor mapping is also become very popular now. So this indoor mapping is this is the equipment. Mobile mapping system, backpack mapping system is the equipment which is best suitable for indoor mapping. Now coming to the unmanned aerial system. So unmanned aerial system, surveying grade drones, the importance of drone is nowadays become very popular for survey grade. Why? Because suppose if any land parcel mapping, if suppose we are doing a resurvey project in Andhra Pradesh, if you wanted to show the farmer who doesn't know about this GPS, drone, LiDAR and all, we will be going with the GPS, taking the corners of the measurements at the corners, and we are drawing a polyline. So we are showing the farmer, this is the polyline, this is your land boundary, and this is the extent. Suppose if it is as per his knowledge, because in his old books or from the parents, he will be coming to know it is at 1 acre or 2 acres. If it is within that limit, he will be quiet. Sometimes because of the record problem, sometimes because something there will be some error. Less, if it is less, definitely some doubt will come into his mind. But if you do a survey with a drone, you will have a image, orthomosaic image like a Google map on your hand with an accuracy of 5 to 10 centimeters. If you show by drawing a line in front of the farmer, this is your boundary, you see, your visibility is there, draw the boundary, and this is the extent. So he is able to understand what it is actually. Okay, further he will, whatever it is there. So this is the main importance of that. Now, Government of India initiated some project like Swamitwa and Naksha through Survey of India. The purpose of Swamitwa is for each and every village boundary, that's called as Abadi. Drone will fly, they will take the image of the drone, and the taxation, local taxation of the panchayat will be done based on the images from the drone, 3D images from the drone. Because in manual systems, if your plinth area is so much, somebody will come and he will measure manually and he will write. Whereas in this case, it is a documentary proof. Whatever is the plinth area from the imagery, drone imagery, we will measure and we'll say this is the plinth area, this is your tax. So the taxation will be very fair and genuine. Now this Naksha, for urban it is. They are doing in for Swamitwa, we are doing only 2D. There is no 2D in 3D. The height is not considered there. Whereas in Naksha, we are doing 3D plan, 3D mapping. That means Survey of India is doing a 3D mapping for all urban municipalities. So initially for pilot project, 6 or 5 towns they have selected. Once the pilot project is over, it will be implemented across the country. So the primary purpose of this is, again, what is the boundary of your building and how many floors you are constructed, or what is the height. Is there any violation or not? With clear-cut documentary evidence, we can select and we can implement our taxation system with a documentary evidence and without pakka as per the built-up area. This is the main purpose. For this, because we cannot use aircrafts and all, because the aircraft flies at very high, and then urban areas flying an aircraft with industries and all are very risky, and it has to be fly at a very high height. Whereas the drone, it flies at 150 meters to 200 meters or 300 meters. So it gives a very good orthomosaic image. Once the drone is come down, we process the data and we will create an orthomosaic, and the data will be given to the concerned authorities for the taxation purpose. Why the drone is, how the drone is, it is an aerial unmanned aerial vehicle, UAV will call, to capture the aerial data downward facing the payloads. The payload is nothing but a camera that is called as RGB camera, multispectral camera. And RGB is the camera which is used for mapping application. Multispectral camera is for agricultural and other application. And LiDAR payloads for point clouds. RGB means a camera takes the photographs and we will stitch those cameras, and from the camera the software will generate the orthomosaic. Whereas the LiDAR data directly creates a 3D surface of the existing surface, and the camera is built also there. A photo imagery on top of that point cloud data it will give, and it will give us the clear cut. During the drone survey with a mapping payload, the ground is photographed in a regular intervals, and then each image is georeferenced. Because in GP, nowadays in drones is coming up now, drone industries come up with in drones inbuilt with a GPS, that is called as PPK drones will come. There will be a GPS inside the drone. During the flight of the drone, the GPS will collect points of the entire flying path. The camera will keep on taking the images. So once the drone is down here, once the drone lands and will download the photos to the, and once the photo is downloaded, all the photos are downloaded, we will there will be a time tag for the photograph as well as the GPS data. Based on the time tagging, we will georeference all the photographs. That means every photograph which was taken as a raw photograph will be given a coordinate system and will be converted to a geo coordinate system by the software from the data of the drone. Once the data, photographs are all geo-referenced, depending upon the software, we will give the overlap and front overlap and back overlap. The software will stitch the photographs and it will create an orthomosaic. So these orthomosaic will be a geo-referenced orthomosaic. Wherever you click, there will be a position, XY position. Then the data will be further processed to generate the point clouds also to get the 3D dimensionals. So once the orthomosaic is generated, we can draw the lines, we can measure the distance between the points, we can measure the height between 2 points. All those can be done, and it can be exported into the third-party softwares or AutoCAD software for our further analysis. Benefits of drone surveying: it reduces the field time and survey cost, because once you fly the drone, your entire location map will be there with you again and again. If you require some data, no need of going to the site. You can just keep opening this particular drone in orthomosaic data and we can do that. Then provide accurate and exhaustive data. Exhaustive data means that's what? Huge data. If you can fly the drone to the entire Vizag city, or maybe the different kind of drone. Some drones will fly up to 90 minutes, some drone will fly up to 20 minutes. And some drones nowadays, the recent developments are coming in, even 2 hours also they will fly. For 1 hour, one flight they will be covering around 5 to 6 square kilometers. Like that, huge, some 100 square kilometers also we can have a drone data, and which is readily available with us. Also, some inaccessible areas. Suppose some area is there, it is water ponds. We cannot go into it. Otherwise, it is a filled with water and other grass and all. We cannot go and step inside. But we want the boundary of that particular location. We're not interested inside, but we want the boundaries of the particular location. But we cannot reach the other side. So in that case, if you fly a drone on top of that and get the images and then do the work, we can easily get the area and other features which are all available inside that harsh locations. Drones land surveying we will use, cartography we will use, even in land management development, precise measurements for this high resolution orthomosaics and all. Volumetric analysis also drone use. If there is a stack, if you fly the drone, it will give us the 3D image, the 3D surface. From 3D surface, we will get the volume. Security and surveillance. This is a different application of the drone which is used in the military and defenses and other security people. there will be a security video camera will be there. The video camera will give us the image. And even police department, very often they are using these drones to catch the illegal mining, illegal entries and the high security areas and all. Urban planning, now we are talking about Naksha project. They will fix the control point with GPS, then drone they will fly. They will get a 3D image of the entire building, every building. So they will measure, and there is entire urban this thing can be planning, can be managed using the drone image data. This is the other project data taken, photographs taken by the drone and was developed by the software. Now, whatever it is required, wherever you are required any feature, suppose I want this boundary, just draw lines here and export to AutoCAD. So I want the height of this, just click here, we'll get the height. So we have a 3D image of our entire surface. Whatever feature we require, we can easily extract that feature from this image. Auto maps, the 3D evaluations, if I wanted to do some 3D evaluation, so what is the height of here and what is the height of here? If there is any pipeline or any elevated reservoir has to be constructed, what is the best location as per the elevation height, we can easily plan. We can easily digital surface model, DSM, we can make it, digital terrain model, DTM, we can make like this. From the same data, we can create all these kind of surfaces for analysis of the volumetric or contouring generation or for the drainage system development, whatever it is, as per our project requirement. This is the contour lines. For this entire surface, contour lines can be represented. But only thing, a problem in the drone survey is, even these buildings also, if you are not trimming this, it will take the buildings as a surface and it will create the contour. If you want only ground, generally contour maps we will create from the ground levels only. So there are softwares now. These softwares can trim and remove all these unwanted surfaces. Wherever you select the polylines, between the polylines for the entire building, it will create a contour and it will generate the contour. This is for stockpile volumes, volumetric analysis. So how much is the cutting volume, how much is the filling volume? With one click, we will get the volume and values. This is the brief about the survey techniques, which was evaluated right from the chain and tape to the drone technology as of now. So it is in brief, but every vertical has its own application and huge application. If I talk about tunnels, it is a big. Even if I talk about monitoring, even high-rise building also, there is a separate subject and separate software. Same equipment, same deployment, like a total station, robotic total station, we can do the monitoring there. Even for bridges and some structures where the high-rise structures, not in here, Delhi and all, some high-rise structures are there. There will be some swing with the wind and all. That swing also will be monitored every day. And also for dams, when the dam is completely full and the gates are open, what is the deflection of the dam? That also there are equipments which will monitor those deflections, and that directly the deflection will be transmitted to a computer, and from there it will reach to the headquarters. So different kind of technologies are there, but this is a brief about all these technologies.
Thank you, sir, for your inspiring talk. Your insights on geospatial innovation demonstrated how technology can empower national development. We are grateful for the time and effort you took to share your expertise and perspectives with us. I'm sure the participants have gained valuable knowledge and inspiration from your session. On behalf of the organization team and all participants, we extend our heartfelt thanks to you once again, sir, for this informative and thought-provoking presentation. Dear participants, now we'll proceed to the interactive question and answer session. Participants can post their queries in the chat box.
If you have any doubt about this, you can write mail also. Madam will share my mail ID to all you.
Sure, sir. Sir, questions are there. Shall I read questions, sir?
Yes, madam.
So question, how can AI and machine learning be integrated with geospatial data for better planning and decision making?
Yes, sir. So that recently, just one slide I told you, the software. Because once you collect the data, when you are doing a street survey and collecting data with a scanner, So it is there are a lot of laws will be there. The moving vehicles will be there. Some objects, which is unwanted objects, will be there. And also some patches will be there. Don't require. So there is this AI algorithm is a tool in which I can create one protocol in my software. I don't want to get the moving objects into my scanning data. So the scan data, moving object means it is a blur. So the software will automatically recognize that kind of objects, and it will remove that objects from the scan data, and will give me the pure scan data which was stable and actual surface. Like that for every application, like I told you, electrical pole. I can create one shape and I say this is electrical pole. If I say electrical pole, whatever is the scan data is matching to that particular shape, the software AI algorithm will identify that, and it creates a layer and it puts all these kind of things into that same layer. So I can switch on and switch off the layer, and I can play those kind of by whatever data I require. I can easily manage my data, and I can do further analysis using what is important for me. Likewise, every software has its own advantage, and AI is also playing a crucial role in that data cleaning and data analysis. Customization can be done in the software using the AI tools.
Thank you, sir. Sir, one more question, sir.
Yes, ma'am.
Hello, sir.
Yes, madam.
Sir. How much these composites will be favorable to our environment, sir?
So there is no environmental is 100% safe to our environment except drones. Only the battery is the component which is having manufactured, and for this equipment only the battery is the component. Other components are there is nothing they are not doing any harm to the environment. Even drone also, all these components are nowadays coming with fiber optics or FRP, fiber reinforced protection material. So these are all environmental friendly except batteries.
Okay, sir. Sir, one more question. How results obtained by advanced surveys can be validated?
Can you repeat that question, ma'am?
How results obtained by advanced surveys which can be validated?
Okay, validation means suppose that's what drone we are doing that. We are how I will tell you an example. Drone survey. Before flying the drone, we will fix some control points on the ground with GPS. Those control points are not with RTK. We'll do the static observation. That means 30 minutes to 1 hour we'll observe. We will process the data with Survey of India. Once the drone data is processed and drone data is orthomosaic generated, we can see that particular portion in our orthomosaic map. So this orthomosaic is georeferenced with the data from drone data, GNS data. If I click there, there will be some coordinate there. The value will be displayed. We will check our pre-survey drone flying data, our control point data with us with the data. So the validation will be done using that control point data checking. That is called as ground truthing. We will validate this data by ground truthing.
Thank you, sir. So many participants were asking to share your contact details, sir.
Sure, madam. You can share my contact details. Otherwise, I will put it here.
Sure, sir. Dear participants, if there are any queries, you can post your questions in your chat box here.
Sir, good evening, sir.
Yeah, good evening, sir.
Sir, myself Giridhar.
Sir.
Sir, is there any special permissions required for drone survey?
Yes, sir. Drones nowadays, drones are different. Two are the key permissions. So one is that whether this drone is approved by DGCA.
Okay.
So nowadays, most of the Indian manufacturers are having drone DGCA license certification for that. That is the number one. It is required. The second thing is the pilot license.
Okay.
For pilot license, it is only a 10th class qualification is required. There are many certified agencies are there, which are all authorized by DGCA to train the people. So there are training programs right from 1 week to 30 days, depending upon the course they are joining. Once the trial survey is completed, these two are the mandatory for drone flying, sir. Whether the pilot who is flying the drone must be having the DGCA pilot certificate approved by DGCA agency, and the drone which we are flying, the manufacturer must have DGCA approved certificate.
Sir, is there any, student version for Trimble Business Center?
Yes, sir. There is a student version for Trimble Business Center. It comes with 8 modules. Generally,
Okay.
Trimble Business Center intermediate only for DGPS processing, advanced only for AutoCAD and volumetric analysis. But student version comes with photogeometry, drone data processing, aerial, volume, cross sections, L sections, DGPS data and total station data, auto level data. But that will be sold only to the education institutions, sir, not for commercial people. Like in
Only
GitHub,
for
we have
educational institutions.
only for education institutions. It comes with
sir.
8 and 10 user license. You can install in your server, and 10 users can access that license at a single time.
Okay, sir.
That is
Thank
for
you, sir.
laboratory purpose. Yes, sir.
Sir, one more question, sir.
Yeah, ma'am.
How much these composites will be favorable to our environment, sir?
Madam, there is no environmental hazard components in this equipment except for batteries. All
Okay,
other components are environmental friendly. Mostly chips, that is electronic waste, and then FRP boxes, fiber reinforced protection, that is actually reusable ones, those are. Then iron poles and all, these are all reusable. Main components is battery, madam. Then up to some extent, the chip.
Okay, sir. Participants can post their queries in chat box. Thank you, sir. Your session is very informative and very interesting, sir. We are very grateful for your time and effort, sir.
Thank you, madam. Thank you.
Thank you very much, sir.
So
With
thank
this,
you all for your patience in having interactive session. Thank you very much. If you have any doubts, you can reach me on my mobile.
sure,
And
sir.
you can also have my mail ID from madam, and madam will give
Sure,
you the
sir. I'll
answer.
share your contact details, sir.
Yes, ma'am. Thank you. Thank you very much. Thank you very much. So have a nice time. Thank you very much. I'm leaving.
Thank you, sir.
Thank you.
Dear participants, with this we conclude today's Day 2 sessions of our ALCTE ATAL Faculty Development Program. We sincerely thank our esteemed resource persons and all the participants for their active involvement throughout the day. Participants are kindly requested to fill out the feedback form for today's session. I request participants are kindly to fill the feedback form. The ATAL FDP will resume tomorrow with Day 3 sessions featuring more enriching lectures and discussions. Thank you all and have a wonderful evening.